liters. No? So this is conversion. The question here is compute the output power of the pump, no, in kilowatts and the pressure head at 0.1 and at 0.2. So yung power output ng pump, no? So as discussed before, basta pump yung pinag-usapan, yung added energy sa system, that is an output energy. Yung input kasi ng yung input power diyan is yun yung input from the electrical para gumagana yung yung pump. So electrical yung input power. The output is yung effect yung pag-increase ng head ng water, right? So the pressure head 1 and 2. So we know na yung power is a function of, di ba, the discharge. Ano ba yung formula ng power? Power is Q gamma times the head, no? So the head added by the pump. So meron tayong Q, that is 20 liters per second. Ang problema lang natin is yung head added. So the only solution here, no, is Bernoulli energy equation. So tandaan, titingnan nyo lang, na basta pipe problem, sigurado Bernoulli yan. May motion ng liquid. So this is Bernoulli, tapos may mga elevation. Isa lang ang dyan is Bernoulli energy equation. Okay, so let's solve the number 1 question, the power output. If you look at the yung mga reviewer, no, may mga reviewers sila, Visa, Jelisanya, yung mga bagong lumalabas na mga review center ngayon, may even mga bata, meron ng mga libro na mga fresh graduate, may mga oras, lalo ngayon pandemic, ang daming gumagawa ng video. Okay, so iba't ibang solusyon, but so far ang pinaka madali na solusyon, madaling intindihin, no? In short, it may not be madali siyang but madaling intindihin is gagawa ka ng energy grid line. Drawing ka ng energy grid line. So, ano ba yung energy grid line? 'Di ba? Ang sabi natin before, ang energy grid line is yung total energy. Kasama na yung pressure, elevation, at saka yung velocity. 'Di ba? So, halimbawa, gawa natin ng ng energy grid line. Okay. So, ito siya. Yung total energy level at point A, kaya nating magawa ng energy level. Asaan yung energy at A? By the way, kung yan, reservoir, malaking yan, 'di ba? Ina-assume na malaking surface area. Okay? Punta kayo kahit sa probinsya, may mga tangke, 'di ba, doon sa sa project nung yung yung barangay, yung barangay water, yung mga malit na tangke. Kahit tingnan mo dun sa say 5 by 5 meter na tangke. Okay? Kahit na ginagamit ng community yan, hindi naman mabilis talaga yung surface area, di ba? Kaya ang energy level actually, yung pagbaba ng surface area, hindi naman ganun kabilis eh. So, yung energy level at A, normally it should be at the top of the surface. So nandito siya. Okay, so kung i-connect mo yung tapos yung energy level at B ganun din, nasa taas ng surface B, nandito siya. All right? So yung energy level at 1 and 2 somewhere nasa nasa mas mataas or mas mababa sa sandali okay? Halimbawa, yung energy level at 0.1. So pwedeng so nandito siya sa banda siguro, no? Ito, ayan, pwedeng yan yung energy level at 0.1. Hinahati yan sa velocity at saka yung pressure. So, ang importante lang, di ba, kaya diniscuss ko ng maigi is yung energy level, di ba, may mga basic concept yon. The energy grid line always goes down in the direction of flow. If our flow is normally, yung A is nagsusupply yan, di ba? Kasi mas mataas yung A kaysa dun sa pump, nagsusupply yan. Okay? Tapos ito naman, pataas yun. So, ang tatandaan natin is, yung energy grid line, it always goes down in the direction of flow. Bakit? Dahil may friction loss. So, halimbawa, okay, at A, ang energy level is ito siya, ito yung energy level at A. at point 1, yung energy level, most likely, somewhere here. Nandito yung energy level. Okay? Uh, hindi siya aabot sa level A. Bakit? Dahil may head loss. Okay? So, kung idodrawing natin ng maayos, ganito yan. Okay. So, the energy level, no, energy level at A is nandito sa elevation 0. Kaya na-move lang ng konti. Anyway, so ito yan. Nandito yung sinasabing A, elevation 0. Yung energy level at A is at elevation 0. Nasa surface ng water. No? Nasa top surface ng water. So, since ano yan, tangke yan, so there is no, ina-assume na walang velocity. So, there is no velocity head. So, therefore, the energy level is nasa top surface. So, tandaan nyo yan, basta mga tangke, nasa top surface yan. So, it goes down up to point 1. So, the energy level goes down in the direction of flow. Alright? Kung walang head loss, horizontal lang yan. So, nandito lang yan, horizontal. Okay? Since may head loss, kaya may sinasabing friction loss, di ba? Kanina sa problem, may sinasabi. So, meron yang bababa yung energy level. So, yan is at point 1. So, ito yung energy level niya. So, at point 1 before the entrance of the pump. So, ngayon, may pump. So, tataas yung energy level. Kasi may head added yan eh. Kaya nga, kailan yun ang hinahanap natin. Yung, how much is the energy added by the pump to the system. So, pag may pump, tataas yung energy level. So, tataas yan. Ganyan. No? Or pwede, yung iba, pwede vertical. So, tinagilid lang natin ng kunti, no? Para lang may itapat sa point 2. Kasi sa exit eh. So, ngayon, the vertical level between from point 1, no, yung difference kumbaga ng energy grid line is yun yung head added. So, from here, right, up to here, no? So, that is the head added vertically. So, measured vertically. So, ito yung head added. No? So, whatever this one is the head added. Ito yon. Yan yung head added by the pump. Ito yung hinahanap natin. Head added ng pump. Okay? So, at point 2, point 2 to point B. So, yung flow is from 2 to B, right? So, therefore, ang sabi nga natin, ito lagi yung pinaka-principle sa Bernoulli, no? The flow is always, the direction of energy grid line always goes down in the direction of flow. So, if yung flow kasi is from point 2 to point B. So, ibig sabihin, yung point 2, yung energy level, mas mataas siya sa point B. Otherwise, hindi yan mag-flow, mag-backflow yan. Or kung zero discharge, okay, kung walang discharge, dito yon. Ito yung energy level lang niya at point 2. Kung walang discharge. Alright? Ngayon, since may discharge, ang sabi natin, it always goes down. Kaya ang energy level, ganyan. Maliwanag? So, this principle is very significant and important in solving pipe network. Kaya mapapansin nyo sa mga, may libro kayo, may akong sinishare sa inyo, praktisan nyo, pag barating sa pipe network, hindi pwedeng mag-solve ka ng problem na hindi ka draw ng energy grid line. Otherwise, mag-i-imagine ka lang. Okay? So that is a basic principle. Energy grid line always goes down in the direction of flow. Dahil yan sa friction loss. Alright? So dahil sa friction loss. Ito kasi may friction loss sa pipe kasi may binibigay na, although yung length hindi na sinasabi, binibigay na yung amount of head loss. Okay? So from A to okay? So ito yung energy grid line, yung dash line. So yung from A to point 1, no, yung vertical difference ng energy grid line ng A and 1 is yan yung head loss ng A to 1, no? So tatlong tatlong vertical. So H1 yung head added, ito yung measure natin pula or head added, at saka yung H2. Yung H1 at saka H2, di ba, na yan, given na yan, in terms of the velocity head. Alright? So, with the, itong energy grid line, makabuo ka na dyan ng equation. ano bang unang hinahanap? Is power. Kung makuha ko yung HA, puro lang naman yan, difference in elevation. Kung makuha ko yung HA, tapos na yung first question. Then, ang isang question is pressure head at 1 at saka at 0.2. Okay? So, yung total energy, as discussed, di ba, hinahati yan sa dalawa. Let us say at 0.1, yung elevation niya is elevation minus 2. So, hinahati ito sa dalawa. No? Meron tayong, ano ito? Ito is the pressure head. Tama? Ito yung P over gamma, and ito yung isa is velocity head. So, ano yung velocity head? So, B square over, okay? B square over 2G. Right?
2G.
B square over 2G. So, that is velocity 1 over 2G. Tapos, ito naman is P1 over gamma. Ano, wala tayong variable dito sa ano. Anyway, so, ano na lang, over G. Gamma or ano. P over gamma yan. So, that's pressure head. Okay? So, wala akong anyway, P over gamma. Gamma na lang para, yes, para, ayan, P over gamma. So, pag meron ka nang nabuo na ganyan, actually, more than kalahati ng ano, tapos na. Tapos na ang usapan. Pag pipe network, energy, energy. Basta may mga pump, turbine, ang solution ko lagi is, lagi ako nagdo-drawing ng energy grid line. Kahit na may mga submerged pump, mag-negative yung pressure, I always use energy grid line. Kaya maintindihan mo yung equation. Okay? Kasi plus and minus lang yan. Halimbawa, ito. Ayan, meron ka ng pwede kang energy equation from A to 1 or pwede A to 2, pwede 1 to 2, pwede A to B. Ayan, gano'n. So, depende sa'yo. No, kung saan mo i-apply. Motion ito ng liquid. So, parang dynamics ito. Kaya parang motion problem. Motion from A to B. 1 to 2. 2 to 3. So, gano'n. Gano'n lagi yung ano. Kasi, conservation of energy ito. Energy A equals energy B. Total energy at 1 equals total energy at 2. Right? So, Bernoulli energy equation, meron tayong kailangan na continuity equation, di ba? Q1 equals Q2. So, ganun dapat. Kasi kailangan natin yung velocity 1 at saka velocity nung pipe number 2. So, A1, V1 is A2, V2 is, of course, that is 20 liters per second. Diba? Yung V is the Q, where Q is 20 liters per second, and the conversion is 1,000 liters is 1 cubic meter. So, what is this 0.02? So this is cubic meter, right? Per second. No? So ayan yung unit ng 0.02. So is yung diameter ng 1 is 0.15, diameter ng 2 is 0.1. Then you can solve the velocity by substituting this diameter. Pi over 4, 0.15 squared V1, pi over 4, 0.1 squared V2 is 0.2. 0.2 divide pi over 4.15 squared. 0.15 squared is V1 and also V2 can be solved. So, ganun lang. Lagi yan, papapil sino yan? Constancia. That is continuity equation. So, ito yung continuity equation. Lagi yun. Lagi. Hindi pwedeng hindi mo magagamit yan. Kasi dalawang point lagi ito. No? So, continuity equation. Now, let's start. Ang unang kunin ko dito is yung HA, head added. So, asan ako mag-apply ng equation, ng Bernoulli equation? Etong past board exam na to, maraming hindi nakakuha kasi naguguluhan na. Kasi, sa sample problem, wala namang negative. Pagdating sa board exam, negative pala yung elevation. Okay? Actually, yung elevation is basta vertical distance lang ang pinag-usapan. Halimbawa, A to 1, that is 20. So, pwede mo, ang reference mo, actually, pwede kong baguhin ito eh. Yung pinakailalim, pwede kong gawing 0, yung elevation A, 20, yung elevation B, plus 20. So, pwede kong gawin yon, no? So, pwede rin hayaan mo rin na ganyan. Basta, consider mo rin yung sign. Okay? So, Bernoulli energy equation, by the way, yung head loss 1 is 3 times, di ba? Tapos 20 times yung head loss 2. So, 3 times ng velocity head, so 3 times the V1 squared over 2G, that is 0.95 meter. No? G is 9.81. Yung H2 naman is 6.6, no? 6.6 meter. So this should be H2, right? So that should be H2. So ang problema mo na lang dito is actually yung H1. Base dyan sa H1 na lang ang problema. So you can have maybe Bernoulli equation from yung known. Wag kang mag-apply ng Bernoulli equation, let us say A to 1. Kasi anon pa dito yung pressure alam natin yung total energy is velocity head, elevation head, at saka pressure head. So ang unang kailangan din yung A, di ba? It's A. So the best here is dito ka mag-apply ng Bernoulli equation A to B. Bakit? Kasi yung pressure at A, elevation at A, velocity at A, di ba known? Right? Yung B, ganun din. Yung pressure niya is what? Di ba? That is atmospheric. Ang pressure is 0 gauge. Okay? Velocity, that is 0. That is tank. Surface area, there is no change in velocity. Even mag-move yung water. Okay? Elevation, meron. So the only points that you can consider to solve each A is applying energy equation from A to B. Ayan. Right? Energy equation A to B. So, yung EGL, actually, from EGL, yung energy grid line. Or, actually, in short, yung sinasabing A to B is, ganito lang yon, no? Para mas klaro. Yung total, di ba, kasi A tayo, no? A to ano. So, yung energy, yung total energy level, no? Ng A at saka B, if our datum, pwede kong sabihin yung datum, galing sa pinakailalim, tama? Yung total vertical niya ng A at saka total vertical nung B, okay? So, saan siya? Ito, pwede ito, ayan. Di ba? Ayan. So, may transformation. Halimbawa, yung A na may elevation siya. Kung ang reference natin is, ito yung reference natin ng elevation, so meron akong elevation energy. Ito yon, tama? Tapos, etong sa taas, meron niyang, tawag nito, merong velocity at saka supposed to be velocity at saka yung pressure. Pero, ang nangyari is, etong is walang pressure, walang velocity kasi open. Ayan, di ba? Ayan. So, ito yung energy level at A. Okay, sa left side. Ang energy level at B naman is supposed to be at itong nasa pinakataas. Dapat ganon. Pero, yung ang pinaka-final talaga, since wala namang velocity, walang pressure, ang pinaka-final energy level at B is nandito lang siya. So, kumbaga, yung vertical at A at saka vertical at B is supposed to be parehas yun. No? Supposed to be parehas. Okay? Pero kasi may mga added system kasi. So, bumaba tapos tumaas. Okay? Pwede ganito. Total energy at A is ito, tapos total energy at B is ganito sa right side. Kung gusto nyo, minsan nakakalito pag ganyan, no? Lalo na pag may added system, may pump or may turbine kasi hindi mo totally ma-equate vertically. Ang susundan mo na lang is yung elevation. Halimbawa, ganito. Ito ipapakita kong solution sa inyo. Yung from elevation A, okay, elevation A tapos pababa. Okay, so yung equation ko is ganito. Elevation A minus head loss 1. Okay? From elevation A minus head loss 1. So ano yon? So ito yung elevation A pababa minus head loss 1. Where elevation A ko is 0. So from 0, pababa, it's 1. Tapos, head added, so pataas. O papunta sa taas, so plus, head added. Downward minus, upward, pataas. Diba? So, dating dito, plus head added. Tapos, pagdating sa taas, meron tayong head loss from 2 to B, and that is H2. Alright? So, yun na. Walang pressure, walang velocity. So, the final energy level at point B is elevation 240. Alright? So, ngayon, So in this solution, okay? So yung reference ko dito is from yung pinaka 00 kasi I'm using 240. Sundan mo lang yung pinaka elevation niyan. Okay? So, napapansin mo, hindi pumasok yung minus 20. Kasi in between yan eh. Ang kino-consider mo kasi is A and B. Di ba? So, 0, the head loss 1 and 2 or H1 plus HA, then minus head loss 2 equals 240. Parang sinusundan mo lang. Meron ka ng H1, meron ka ng H2, you can solve head loss, head added ng pump. Right? So, HA is 240 plus 1.95 plus 6.6. That is 246.8. Nakuha? Di ba napapansin mo, hindi pumasok yung papel nung minus 20 diyan. Kasi ang kino-consider mo lang is yung elevation A at saka elevation B. Ngayon, saan ko ni-refer yung diyan, yung elevation? Of course, kasi ang pinaka-datum natin is itong elevation saan ba? Yung elevation 0. Sorry. Ang pinaka-reference natin ng datum is elevation 0. So, ngayon, sir, kasi 'di ba yung pag ng energy, concept ng energy, kahit saan ka mag-refer ng elevation, pwede ka rin mag-refer ng elevation dito. Kung ito yung datum mo, so yung elevation A ko, meron niyang 20 meters. Pero ang datum ko for this solution, itong solution na to, ang datum ko is elevation 0. So, hindi na pumapapil ang minus 20 sa usapan dahil hindi naman siya kasama sa pag-apply ng energy equation A to B. Mamaya, pagkuha sa pressure head at 1, kailangan na yung minus 20 diyan. Okay? So, since meron na akong head added, so meron akong Q, I can solve the power output ng pump. Q gamma head added, so that is power output. Q is 0.02, 9810246.8 ang head added, then the power is 48,421 watts. No? Divide 1,000 kilowatts or divide mo ng anong conversion para maging horsepower? 1 horsepower is anong conversion? 1 horsepower is 746 watts. No? You can divide it by 746, then you can solve divide mo ng let us say kilowatts. Divide 1,000 kilowatts. Or you say 1 horsepower is divide mo ng 746. Kung kilowatts yung nasa choices, then yeah, no problem. There's no conversion. No? By the way, calculator have the conversion ng watts to kilowatts. No problem. You can have it sa calculator. So anyway, ang tanong nito is in kilowatts. So no need to convert. Now, the other question here is the pressure head. No? 1 at saka 0.2. So dito, since meron ka ng head added, then you can apply energy equation. From A to 1, pwede from 1 to B, depende sa'yo, ang sagot parehas lang. Kasi meron ka ng head added eh. So you can play now sa energy grid line. So halimbawa, energy level from A to 1. So anong reference ko? Pwede ko ang reference is yung datum na lang na 0 sa elevation. Leave it kung ano yung sinasabi niyang mga elevation. Okay? So, elevation 0. So, A is at A, ang total energy is at the surface. That is elevation, what? Elevation 0. No? Then, at 1.1, ang elevation niya is minus 20. Or pwede mo ring balik na rin. Ang datum mo is nasa ilalim, ang A mo is 20, yung pump mo is 0. It's up to you. Ang sagot, parehas lang naman. Alright? So, halimbawa, I have here, elevation 0 minus head loss 1. Okay? So, ano yun? Elevation 0 minus head loss 1. Di ba? Saan yan? Yung elevation 0 minus head loss 1 is, ito yon, nandito. Okay? That, energy level, okay, kung gusto pang bababa, minus ka pa ng B1 squared over 2G, then minus ka pa ng P1 over gamma. So, nasa level ka na ng, saan ka na level? Nandito na ka sa level ng pump. Tama? And this level of pump is this elevation minus 20. So, equals mo na sa minus 20. Tama? Ganun lang siya. Ganun siya ka-simple. So, sinusundan mo lang yung energy green line. Okay? So, sinusundan mo lang yung energy green line. So, at A, wala siyang velocity A. Wala siyang pressure at A dahil that is an open surface. That is yung tangke yon. Pero dito sa 1, meron siyang pressure at saka velocity. Actually, pwede mong pagsamasamahin yan eh. Yung at 1, elevation A, elevation is 20, pwede mong pagsamasamahin yan. Pwede actually ito sa itong portion na to nasa right side. O, di ba? Lipat mo sa right side, actually maging positive yon. Kumbaga, vertical distance at A at saka vertical distance at 1. So, pwede mong i-equate yan. Parehas yun. Elevation at saka yung sa kabila is head loss at saka velocity and pressure head. Alright? So, kung makikita mo, meron ka dito? So, meron kang head loss, meron kang velocity, of course, velocity 1, meron ka na, di ba? 0.132. So, b squared over 2g, kaya naman solve yun. And meron kang, ang P1 ang hinahanap or P1 over gamma. Yung question dito is find P1 over gamma or the pressure head. So, ganito lang. So, mapapansin, madali lang yung solusyon. No? So, P1 over gamma is minus 20 plus b squared over 2g plus head loss at A. So, may makuha kang P1 over gamma. No? So, P1 over gamma equals 19.74. So, still positive siya, no? Paglipat sa kabila, so magiging positive. So, yun yung pressure, no? It should be positive, of course, kasi paano yan tataas kung hindi yan mag-positive. Positive pressure gauge. So, ngayon, if you want yung pressure head at point 2, then you can apply energy equation A to A1, A to 2, pwede 2 to B, or pwede 1 to 2. No? Pwede 1 to 2. Pwede yun kasi meron ka ng P1 over gamma. You can apply energy equation 1 to 2. Pwede yun. Alright? So, pwede. O pwede rin from 2 to B. Basta, i-connect mo sa at point 2 dahil pressure head at point 2 ang hinahanap. Okay? So, pwede ko 2 to B. No? So, from point 2 to B. Ganun lang din. Left side equals, or pwede sundan mo lang yung energy level. Energy level. Halimbawa, ano yung total energy at point 2? Kitang-kita mo na from ito elevation up to sa taas. No? Nakuha? So, ayan, pwede. Tapos, dito sa kabila, ito yung sa kabila, elevation at saka yung head loss. Equate mo lang yun. No? Okay, so we have here, at point 2, anong meron dyan? Meron niyang pressure at saka velocity head at saka elevation. Yung head added, kasama ba dyan? Hindi mo na kailangan i-consider kasi that is 1 to 2 yan. Ang kailangan is 2 to B. So, ang involved din dyan is yung elevation, pressure head, velocity head, at saka head loss. Di ba? So, or pwede mong, kung gusto mo, left equals to right. Yung left nito is ito yung left. Ayan, yun yung total energy at the left side. You have elevation, pressure, at saka velocity head. Yung sa right side, anong meron dyan sa right side? Elevation at saka head loss. At B, there is no pressure, there is no what? Velocity. Kasi nasa surface. Ang pinag-usapan natin point B is surface yon. So, walang velocity at saka walang pressure. Pero sa point 2, close yan eh. So, merong velocity at saka pressure. Alright? So, ganun lang. Meron ka ng velocity, meron ka ng head loss 2, ma-solve mo yung P2 over gamma. No? So, P2 over gamma is 266.27. So, laki ng pressure niya after nung pump. Yun yung magsusupply doon sa B. kailangan more than 240 siya kasi otherwise hindi yan mag-flow towards B. So ganun lang, ito yung pinaka-principle basic ng energy grid line. Please understand ito kasi pagdating sa pipe networks mamaya, ito lang din ang pinaka-solusyon. It's just simply adding all this vertical elevation in terms of pressure, velocity, at saka elevation. Right? So that is yung second problem about application of Bernoulli energy equation. Right? Okay, so let's move to yung another topic is ito lagi dito sa board exam is about orifice problem. Etong orifice problem is kasama din to kay Bernoulli. Basta anything that merong flow of liquid sakop yan ni Bernoulli. Okay? But also, ito pag orifice problem, modified lang siya kasi instead na mag-Bernoulli ka pa, diretso mo na lang. Simple equation ng orifice kasi hinahanap ito. Find the Q, find the height, find the So, what is important pagdating sa orifice problem is yung pinaka-principle lang ang kailangan yung i-consider. Okay? So, ngayon, halimbawa, meron dalawang case yan pagdating sa orifice problem. Meron tayong minsan meron tayong open orifice, meron tayong submerged orifice, no? So, ano ba yung sinasabing orifice? So, orifice is actually ang pinakamadaling term is any small opening. Any small opening na dinadaanan ng liquid. Halimbawa, yung anatomy ng yung dinadaanan ng ihi, orifice ang tawag doon. Di ba? So, this actually sa hydraulics, ito is mga fluid measurement device, no? Ina-attach sa tangke, no, para ma-measure mo yung flow. So, ito yung mga formula na tawag nito. Lagi nating na-encounter. So, Q equals A times B. Ito naman Q is AB times B. Ano yan? Gamit na gamit ito eh. Alright? So, meron lang ditong mga coefficient of velocity, coefficient of discharge. Anong gamit ng mga ito? So, ganito. Hindi ata na-save yung ginawa. Oh, anyway. Ganito na lang. Yung let us say, tangke. No? Tangke. Sabihin natin may tangke. Ito na lang, tangke. So merong orifice. So yung orifice nasa gilid. Okay? Dito yan yung orifice niya. Pwede sa gilid, pwede sa bottom. Okay? So ngayon, kung may tubig yan, so ang tubig of course dadaan sa butas. Okay? Ayan, dadaan sa may tubig. Ngayon, ang concept kasi nito is ganito. Wala namang concept ng basic concept lang. So, yung liquid, kung halimbawa yung liquid mo is ito yung level ng liquid, no? Yan yung level ng liquid. Ang importante lang dito is yung height, no? Mayroon kang height diyan. Yung height is yun yung sinasabi nating head. Ito head. H. O, H na lang. H. Total H. Ano ba ito? H. O, ayan. Okay. The amount of velocity. Okay? The velocity head. Meron tayong velocity head is, di ba sa tawag nito? Meron tayong velocity head equivalent equals V square over 2G. No? So, paglabas dito, meron kang velocity. That is theoretical velocity. Theoretical velocity is square root of 2gh. Kasi kung isolve mo yung velocity, then velocity is square root of 2gh. Na? Okay. So meron tayong theoretical against actual velocity. Kasi meron contraction, sinasabi nitong yung constriction dun sa opening nung hindi ko na save yung picture. Anyway, hindi ko pala naisama. So meron yang merong contraction. Kaya yung theoretical velocity lagi yan, ito is always, ano yung theoretical, greater than actual velocity. Meron tayong actual velocity. And this actual velocity, ano siya? Actual velocity equals to, ano naman yung actual velocity? So, V actual equals CV times theoretical velocity. Okay, ito nakita niyo sa left side. So, yung equation ng actual velocity is CV times theoretical velocity. And yung actual discharge is contracted area multiplied by actual velocity. Where the contracted area is area ng contraction, CC, multiplied by the area of orifice. Mamaya ko lang doon. So, ganun lang siya. So, ibig sabihin, pag samasamahin mo yun yung actual discharge, that is CC, area of orifice, CV, times velocity. Ngayon, pag samahin mo itong CB at saka CC, ito yung tinatawag nating coefficient of discharge. No? CC times CB is coefficient of discharge. Ayan. Now, this coefficient, if not given, these are all equal to 1. So, walang mga friction loss. Okay? Or discharge loss. Kasi meron din loss loss of energy due to construction nung butas nung orifice. Alright? So, yun yung normally ginagamit natin all throughout sa kahit sa mamaya sa ibang application. Pagdating sa discharge, this always Q actual equals CD times area of orifice times theoretical velocity, where theoretical velocity is square root of 2G Now, sometimes may tinatanong sa problem, compute the head loss ng orifice. Okay? So, ano yung head loss ng orifice? Oops. Okay. Oops. Head loss ng orifice. May head loss pala yung orifice, no? So yung head loss, mas maganda pag nandun sa drawing. Anyway, so yung head loss ng orifice, yung formula nun is ito. Head loss. Okay. Kailangan may drawing. Hindi niyo may makuha masyado. Okay, i-delete ko lang muna ito. So yung head loss, lipat ko lang. Ang equation is b squared over 2g minus 1cb squared. So yung derivation is ito. Tanggalin ko lang muna ito. Okay? So yung derivation is ganito. Ito na yung derivation niya. Halimbawa, meron kang pipe, malaking let's say meron kang malaking pipe, no? Tapos may yung pipe mo is pipe system yan. Okay? Ngayon, tapos naka-connecta yan sa let's say malaking tangke. Okay? Ito may tangke ito, tangke na yan. Tapos lagyan ko ng butas dito sa let's say yung butas ko is nasa gilid. Lagyan ko ng butas dito, no? Ito yung butas ko, yung orifice. All right? So in theory, kung yung height ng liquid is eto, okay? If the height of liquid is dito sa level na ito, okay, so ito yung height ng liquid. In theory, pag open ng orifice diyan, no? In theory, tataas yung tubig up to this level, di ba? Let us say up to this level. Tataas yung tubig up to this level. But in theory, hindi yan aabot sa initial Kung etong initial mo is yung height nun is let us say height h. Assuming ito is height h ito. Height h yan. Dito sa pag-open mo ngayon, kasi yung initial head, pag-open mo, hindi na inaabot sa original height. Hanggang dito na lang yan. May kunting tawag ito, may kunting difference yan. Ang difference niyan is yun yung head loss. Okay? Yun yung head loss. Ito yun. Ito, vertically, so this will be the head loss. Okay? Head loss. Sabihin natin, ano, ito siya. Ito yung head loss niya. Okay? So, ito is the head loss. Head loss. Ano ba ito? Head loss. Okay? Say head loss. HL. Head loss. Okay? Yung sa ano, galing sa ano, ito na yung actual na siya. Head actual. HA. Okay? Actual. So, ibig sabihin, so kung ito is, sabihin natin, ito is H, original H. Yan. So, yung head loss equals to H minus HA. Papansin nyo dito sa equation. So, equals to H minus HA. But yung H is yung kanina, di ba ito yung B square over 2G? But etong ano, yung H actual is B actual over 2G. Kasi paglabas nito sa ano, paglabas nito sa butas, hindi na yan equal to theoretical. Meron tayo dito velocity, ito is velocity actual. So VA. So yung HA is equal yan sa VA square over 2G. So ganun. Pag i-ano mo siya, i-simplify, your VA mo is CV times V. So you'll have head loss is B square over 2G minus yung V actual is CV V square over 2G. Para uniform in terms of theoretical velocity. Kaya yun yung ano, ito yung formula makukuha mo. This is head loss equals V square over 2G 1 minus CV squared. Where velocity is the theoretical velocity. Minsan, ano naman, ang velocity is in terms of V actual. So, i-convert mo yung H in terms of HA. So, pwede rin ganun. Dalawang formulan. But pwede na ito. V square over 2G times 1 minus CV squared. So, kunting ano lang, ang tawag nito, ang kailangan lang is intindihin. Now, I want to, kasi maraming cases ito. So, what I want to emphasize is, ano yung tawag nito? Ano ko lang muna ha? Yung value ng H. So, isulat ko na lang kasi yeah. I-stop ko muna ito. Then, ipin ko itong spot 531. Oops. Okay. Okay. Okay lang, klaro? Okay. So, ito yung importante. Okay. Yung value of H. Okay? Ito yung value of H. Okay. Klaro. Para hindi maklaro. Ito lang. Value of H. Okay? Now, ganito. Meron kasi tayong open at saka submerged orifice, di ba? So ito lang muna pinaka simple case ng orifice. Pwede dito sa gilid, no? Pwede sa bottom. Okay? Pwede ito yung orifice mo. Okay? So yan yung Q. So what is important? Ito yung tandaan nyo. Di ba yung Q natin, okay? Yung Q actual. Di ba meron tayong Q actual? Q actual, di ba ito yung coefficient of discharge, equals area of orifice, then square root of 2GH. Di ba? Kaya sabi ko, etong value of H. Maraming cases. So what is important here is this one. H. Okay. So yung H, ano itong H? This should be height of. Okay? Ito principle to, ang ko sa inyo. Height of. Okay? Liquid. Height of liquid, pwede equivalent na lang. Okay? Height of liquid
height of liquid, okay, flowing out at a time. Okay, flowing out, height of liquid flowing out above above, okay, the orifice. Okay, now this height should be measured. No, this should be above the orifice. This should be up to free liquid, no, free liquid level. Take note the word free liquid level. Okay? Take note the word free liquid level. If this is my height, no? If this is my height, this is my height, this should be a free liquid level. Okay? This should be free liquid level. Okay? Pa-confirm kung narinig nyo?
Naririnig, sir. Confirm.
Malakas, sir. Malakas.
Malakas.
Malakas, okay. Kasi iba yung
Sir,
microphone
tsaka ang
gamit ko
ganda ng sulat mo, sir.
cellphone. Okay. Now, okay. Meron kasing submerged orifice. Meron kasing open orifice. Alright? Tapos, maraming cases kung saan minsan yung halimbawa, ito yung simple case nung yung may submerged orifice. Sa open orifice, open flow, there is no problem, no? Okay, yung paano pag ganito? Ito yung case 1. Case 1. Halimbawa, case 1. Meron akong tangke, simple lang. Okay, ganito. Meron akong tangke, so under yan ng, let's say, eto. Tapos yung orifice ko, let's say, 2 tangke na lang. O, yan, ganito. Tapos yung orifice ko, dito sa gilid. Tapos, eto ngayon is, okay, eto yung liquid. No? Paano ko i-measure ngayon yung H? Okay? Paano ko ngayon i-measure yung H? Ganito. Halimbawa, ito yung out. Actually, this should be between in at saka yung out. Yung in dito is ito. Yung out is ito. But, of course, in one point lang. So, the difference is simply is H. Ngayon, dito, ito yung in, ito yung out. Tama? Do you agree na ito yung in, ito yung out? So yung H dito, head available dito, it should be this one. Okay? Diba? Let us say this is H1. Dito sa kabila, yung head available niya, ito yung sinasabing sa bird's orifice. Yung head available niya is H2. Now, what should be my H? Okay? Kung parehas yung level ng tubig, walang mangyari na flow. Right? Magkakaroon lang ng flow yan, principle of Bernoulli pa rin, kung mas mataas yung head on the left side. Flow goes na the direction, yung energy grid line. Mas mataas yung energy level dito, mas mababa dito. So, of course, pagsusuklay ito. Ngayon, yung H natin dyan is simply, kung ito yung free level, free level, when we say free, anong ibig sabihin ng free? Gauge pressure equals to 0. Free, or ito is pressure is atmospheric, no? Gauge PG is 0, ito is free, right? So, in at saka out, or right, in, then ito is out. Okay? This is simply, H ko is H1 minus H2. Yun yung H na ilalagay ko dito. Right? Yun yung H na ilalagay ko dito. Ang isang case na yung merong Mayroong pressure, halimbawa. Okay, halos ganyan din. Ganito ang gagawin ko. Okay? Oh. Okay? Oh, yan. Now, paano pag ganito? Ito tangke, sarado. Okay? Tapos meron tong under pressure. Let's say meron akong P1. Alright? Tapos meron niyang tubig. Any liquid. Okay? Ngayon, tapos sa kabila, may isang tangke na of course pwede malaki or whatever. Tapos meron niyang liquid, in this case. Tapos meron under pressure P2. Ngayon, may butas dito. Okay, may orifice dyan. No? Sabihin ko, ito is head liquid level 1 and ito is liquid level H2. Okay? So yung flow of liquid, saan? Yung flow ng liquid is papunta dito sa right side. Ngayon, okay. If you are asked what is the discharge, of course you will use this equation. CD area orifice times square root 2gx. Tama. Ngayon, ano ang value of h na ipapasok ko dito? Okay? Na ngayon, pag hindi mo naintindihan, paano ko ba ano ba yung h na ilalagay ko diyan? So tandaan nyo, yung tubig, there is no flow if there is no difference of energy. Kasi kung parehas ng energy yan, walang mangyaring flow. So level na siya. Maliwanag? So kung mayroong flow yan, malamang mas malaki yung pressure at saka elevation dito sa in short, mas malaki yung energy available dito sa side na ito kaysa doon sa yung in kaysa outside. Tama? Mas malaki. Ganito lang 'yon. Ganito lang 'yon. Kung magbutas ako dito, etong sa level na ito, maglagay ako ng pisometer. Alam niyo yung pisometer? Yung hose, halimbawa sa mga tangke ng yung mga tangke ng water tank, meron yang may, di ba, may hose yan sa gilid. Tapos makita mo yung level ng liquid sa ilalim. Kung maglagay ako ng butas dito, maglagay ako ng pisometer, meron akong makukuhang level, no? Maglagay ako ng hose, tataas yung tataas yung tubig, di ba? Do you agree na may makukuha akong tubig, no? Aakyat yung tubig dahil sa pressure, tataas yung tubig up to, let's say, a certain level, no? Okay? Meron tayong level dito. Meron tayong level. And that level, sabihin natin Y1. Let's say this let's say this sabihin ko lang ito is A and ito is B. So, etong level na ito this is PA over gamma. Tama? Sa kabila, ganun din. Kung magbubutas ako dito, tataas yung tubig. Okay? Tataas yung tubig. Yung itataas ng tubig, of course, magdidepende sa amount of pressure. So, may liquid yan. So, malamang ito hanggang dito siya. Yan, di ba? And this level, do you agree that this is PB over gamma? Tama? Okay? Yung sinasabi kong head at yung head na sinasabi ko is simply ito yon. Okay? So yung H na ilalagay ko dito is simply PA over gamma minus PB over gamma. Okay? And what is that PA? This is P1 plus P1 over gamma, pressure, okay. P1 plus gamma H1 over gamma minus, yung PB dito? Ang PB is, that is P2 plus gamma H2 over gamma. Ito yung pinaka-H na ipasok mo dun sa equation. Maliwanag? So what should be your H? It should be head between head difference. No? Actually, this should be height of liquid flowing out above should be change in height. Okay? Or pwede rin yan. Basta difference between in at saka yung outside. Yung entrance at saka exit. Okay? Meron pang madugo dito. Okay? Okay, yun yung sa merge. Okay? Minsan sa merge, minsan open, pero may board exam, no? Na lumalabas. Okay? Mamaya may problem tayong tanda ito lang tatandaan nyo. Okay? Ito tatandaan nyo. Oops, hindi. Oh. Okay. In case, no? Ito principle to ha. Ito tandaan nyo ha. Pag tangke, ito yung pinaka-matrabaho sa lahat. Huwag naman sana, no? Ngayon, ito is isang liquid, no? Let us say this is liquid 1, no? With specific gravity 1, say G1, G2, G3. Tapos ang is ito yung orifice. Yan lalabas yung liquid. So tapos tatlong liquid ito, no? So meron kang let's say isang liquid, tapos isang liquid. No? So anong H ang gagamitin mo diyan? So magkaiba yung magkaibang liquid. So ang tatandaan nyo yung H. Ito yung H, no? Height of liquid flowing out. Kaya sabi ko to, height of liquid flowing out. Sabihin natin ito is salt. Okay? Let's say ito seawater. Let us say ito is water and ito is oil. So lalabas yung una yung mabigat. So ang mangyari niyan, yung H ko dito, let us say ito is 0.1. So kunin yung pressure at 1, yung H ko diyan is eto bali yon. Okay? This H equals to P1 over gamma. So add all the pressure, okay? Since salt water itong lumabas, no? So whatever yung lumabas, yung gamma mo should be salt water. Pag nalumabas na yung salt water, okay? Then yung water naman ang i-convert mo naman yung taas in terms of water or simply ganito lang. P1 kung anong pressure dito, divide mo lang ng gamma nung water o yung liquid na lumalabas. Kaya minsan may isang board exam na tatlong find the total time to drain all the liquid. Medyo matrabaho dahil you have to convert or find out kung ano yung H. So sa H pa lang, gano'n na complicated. Kung hindi mo makuha yung pinaka-principle ng H, minsan mawawala ka. Bakit ganito ang ginagawa niya? Basta yung H, tandaan nyo, it's the height difference, okay, between the in at saka yung out. Okay? Kung ito yung in ng orifice, ito yung out. Kung ito yung in ng orifice, ito yung out. Kung ito yung in ng orifice, ito yung out. Okay? So height difference between in and out. And take note that liquid, okay, should be uniform or equivalent liquid that flows out. Kung ano yung liquid na lumalabas, yun yung height dapat ang kukunin mo. Right? So yun yung principle ng yung H. Right? So pagdating sa problem solving, I believe wala nang problema. Wala akong nakitang mahirap na problem about orifice. Basta naintindihan mo lang yung concept nung H. Okay? So concept nung H, dali lang yan. Okay. So let's try to solve a problem. Okay. So let's see again the problem. Okay, next slide. Okay. So, let's see again the problem. Okay, next slide. Okay. So, let's see again the problem. Okay, next slide. Okay. So, let's see again the problem. Okay, next slide. Okay. So, let's see again the problem. Okay, next slide. Okay. So, let's see again the problem. Okay, next slide. Okay. So, let's see again the problem. Okay, next slide. Okay. So,
problem. So an orifice is placed at the side of 2-meter diameter vertical tank. The center of orifice is 10 meter above the ground, 3 meters, and the 3 meters below the water surface. How far the side of the tank water reaches the ground? Okay. So eto naman, concept ng orifice, no? Velocity, square root of 2gh. Pag sama-samahin sila naman yung projectile motion. This is mechanics actually. So in this actually review nung ito? Review ng mechanics, no? Mechanics. Motion problem sa projectile motion. So ito yung tangke. Yung tangke niya, no? So 3 meters high yung tubig, the center of orifice is 10 meters above the ground. No? Ang tanong, how far from the side of the tank water reaches the ground? Right? So, anong gagawin natin dito? Anong gagawin natin? Ito is just simple. Ano ito? Simple?
Mechanics.
Projectile motion problem. No? So, sa projectile motion, di ba 2D motion ito, no? So far may lumalabas na 3D, but gagamitan muna ng parametric equation, yung calculus yung minsan lumalabas, x, y, z. And find the velocity with a given parameter. But in most problems sa mechanics, projectile motion, 2D lang 'yon. X and Y. So, di ba? Balikan natin yung ito, kunting review sa motion problem. Di ba sa projectile motion, paglabas diyan, ito, so meron yang projection. Anong projection ng motion? Meron yang Y at saka yung X projection, di ba? Yung Y projection is yung Y motion, tapos ito yung X projection. No? Sa projection, kaya nga ang title is projectile motion. Projection of motion. So yung X projection ng motion, di ba, ito yon, right? And the distance traveled X. Anong equation yan nung distance traveled X? Anyway, the motion along X direction, that is a constant velocity. So there is no horizontal acceleration. Pero yung vertical, meron siyang gravity. Kaya freely falling yung vertical direction, constant velocity yung X direction. Ang kagandahan nito sa X direction, isang equation lang. So anong equation nito pagdating sa X direction? So that this X equals velocity X multiplied by time. Di ba? So, multiplied by time. So, yung Y direction, so freely falling equation na yon. Yung, ano ba yung mga equation ng yung V, Y, A, T. Di ba? VB, V2, V1, Y, A, T. Alam mo yung mga equation na ito? Yung tatlong equation. Yung V2 equals V1 times AT. No, yung V2 squared equals V1 squared plus twice AY. No, yung Y equals V1 times time plus AT squared over 2. Memorize niyo ito? Hopefully memorize niyo sa projectile motion. Yung freely falling, yung tatlong equation. Yun lang talaga, dito lang umiikot. Kasi magkasama talaga ito, motion problem, no? Tapos ito orifice sa hydraulics. Minsan nga may naka-incline pa yung tangke tapos inopen yung orifice. So projectile yung motion. So ang concept lang dito sa hydraulics is yung yung pagkuha ng velocity, square root of GH. The rest puro na yan motion problem. Okay? So ngayon ang hinahanap is yung yung X. Yung Vx, no? Yung Vx is equals to actual velocity kasi nasa gilid yung orifice. Paglabas niya, yung X component ng velocity equals to the actual velocity paglabas. Kailangan ko yung actual velocity. Dito sa problem, wala namang sinasabing coefficient. Sabi ko kanina, if CB, CC is not given, that is understood equals to 1. So there is no head loss. So CB automatic equals to 1.0 if not given. So I can solve actually velocity initial. And that velocity initial equals to CV square root of 2GH. My H equals to 3. So, ngayon, 0 yung 1 yung CB. So, ang equation ko ngayon magiging twice of 981 times 3. This VO initial is eto yung sinasabi nating V actual. Right? Yan yung V actual. One unit yung ano, meron pa itong 1.0, 1.0. But of course, 1 times 0 times wala, unity. CB, VO equals, ano ito? VO equals CB times theoretical velocity, that is square root of 2GH. So this VA, since horizontal yung ano, nasa gilid, this VA equals to VX. Ayan, VX equals to VX. So, yung VX natin, alam natin, that is how much? That is 7.67. Meron tayong VO equals to VX. Ang problema mo lang is yung time. Ano lang ito? Projectile motion. So, using the vertical projection of motion, di ba? Ano yung vertical projection of motion mo? So, from, galing sa, dito, papunta sa, papunta, pababa. Yes. Sorry. Papunta, pababa. Ayan, pababa, yan, pababa. So, yung vertical motion. So, yung time of travel of that equals to, anong principle dito? Equals to time t, di ba? Time t yan. Yung ano, yung time travel. Kaparehas lang din yan sa horizontal, kaparehas din yan sa actual. Tama? Parang shadow lang yan Y at saka yung X projection. So yung shadow niya is yung actual instance na hindi pa umabot sa ground. Ganun din yung mga yung actual nasa gitna pa. Yung shadow sa X and Y, ganun din, nasa gitna pa. Pagdating sa dulo, ay parehas, sabay darating yun. No? Kaya yung actual time t, yung projection is also time t. Kaya, since meron akong initial, ang initial ko is, ano yung initial ko dito? Kung ang initial ko at point 1 is nasa horizontal direction, okay? Ano ngayon yung vertical projection niya? So yung B1y ko dito equals to 0. Tama ba? Ang B1y ko dito equals to 0. Do you agree? Kasi yung V1x ko equals to VO. No? Nasa ano kasi siya? Nasa horizontal direction initial. So ngayon, yung V1y ko given, yung time ko is kailangan ko ngayon. Meron akong y distance, 10 meters, meron akong gravity, then therefore, I can solve time t. Ganun lang yan So using the equation, okay, y equals VOY, time t, plus gt squared, actually meron pa over 2 ito. Okay? Sorry, this should be over. Kasi a squared over 2 ito. So this is over 2. Over 2. No? So I can solve what? Time t. No? So I have what? 10, 0 times time, plus over gt squared over 2 ito. Okay? This should be over 2. So over 2. Over 2. So 20 divide 9.81. No? 20 divide 9.81. Then square root. Then it should be 1.43. Tama? Let me check.
Tama, sir.
Yes, tama. Yes. 1.43. Okay, 1.43. Then, of course, meron ka ng time. Then you can solve distance x. No? Considering motion, horizontal motion of a jet. So, x equals vx times time equals vo times time. Then your time is 1.43. seconds,
10.25.
your VO is, or Vx is 7.67 meter per second. You have X equals 7.67 times 1.43, right? 1.43 seconds. So you have X in meters. 10.90, 10.97, 10.95 meters.
10.95.
So that is the horizontal. Be sure in this topic, kabisado mo ang projectile motion and freely falling motion sa dynamics. Okay? Kailangan mo dito. Magkasama lagi ito. Hindi ito mawawala sa board exam. Alright? So, that is simple. Ito pa lang ito. Yung gamit pa lang is V is square root of 2GH. No? Yung pinaka-concept ng orifice. So, pinagsama. Ito ang gandang problem. To be honest, this is my board exam. No? Ito yung board exam mo dati. Hulaan nyo kung nakuha ko yung exam. Ano, ginawa, hinulaan ko na lang. Hindi man ako marunong dati. Hinulaan ko. Jet of water released from a tip of nozzle, discharging at 0.23 cubic meter per second. The nozzle is inclined and upward 30 degrees from the horizontal. If the diameter of the nozzle is 75, find the diameter of jet at maximum height. Ang ganda ng no? Ang ganda ng problem. Ano kaya sa tingin nyo? Kung ang nozzle is 75, ano kaya yung diameter ng jet, no? Kung naka-aim siya at 30 degrees? Ano? Pagdating dun sa so projectile ito. Projectile motion. Ano yung sa tingin nyo, ang motion ganito? Ano sa tingin yung diameter at maximum height? That is at point 2, di ba? What do you think diameter? Is the diameter is less than at the nozzle, which 75, less than 75, or more than 75?
More than.
Guess. Any
More
guess? Less than or more than?
More than.
Any guess?
O less than, sir. Nag-more than si Rico.
Wild guess.
Less than.
Yes lang
Principle.
din. Guess.
Ito, actually, kahit hindi mo isolve, no? Kung naintindihan mo yung principle ng hydraulics, kaya mong mahulaan. No, ako noon hindi ko actually sinosolve ito kasi naiihi ako. Tapos hindi kami pwedeng umihi nung lugi nga kami kasi sa ibang testing center, allowed naman sila. Yung sa amin, stricto yung proctor. Oo, bago magsimula, ihi kayo. Pagdating sa kalagitnaan, ihingi ka, wala. Tapos ka na. No? Ito, nung sinolve ko ito, actually hindi ko sinolve. Pero hinulaan ko na lang.
Pero tumama
Kaya tanong,
ka, sir.
kasi may mga choices, di ba, sa board exam? Ang tanong, kasi may mga choices more than 75, yung may choices less than 75. O ngayon, kung manghula ka, hindi ko lang sinama yung choices.
No, sir.
Ang
More than.
diameter ba at 2 is more than 75 or less than 75?
More
Yan yung
than.
tanong.
More than, sir.
Less
More
than.
than.
Any guess?
Less than.
More than yan. Kasi papasok mo yung
Less than.
nozzle sa sa pipe
Wild
Mas
guess? Wala.
More than.
More than or less than?
Less than. Less than.
Sandali. Wala pala akong hindi ko pala narinig. Okay.
Less than. Less than.
More.
Kaya
More
pala
than, sir.
hindi
More
Less
ko-
than. Less than.
More than. More than.
More than.
More than?
Less
Okay.
than. Less than.
More than, less than. Simple lang yan. Anong pinaka-principle sa hydraulics? Kung may lumabas, di ba? Discharge ito. Yung Q1 equals Q2. Di ba? Do you agree? Jet yan kung jet
Yes.
yan, hindi naman nag-scatter na ganyan. Halimbawa, umihi ka. Simple lang, umihi ka. O yan, umihi ka ngayon. O, di ba ma-adjust mo yung angle? No? Halimbawa, yung muihi ka is wag lang yung yung bagong gising. Kasi mahirap i-adjust yung angle, di ba? Ngayon, ma-adjust mo yun. Ngayon, sa lalaki, madali lang intindihan. Sa babae kasi may medyo ma-adjust mo yun. Makakita mo yung diameter. Okay? Yung principle kasi is, yung Q1 equals Q2. Ngayon, di ba? Ngayon, kung Q1 equals Q2, we know Q is area times velocity. Wala tayong problema doon. Area times velocity. Q is area times velocity. Pero etong at point 2 kasi, do you agree na yung velocity at point 2 is less than velocity at point 1? So, ibig sabihin, ganun doon pa lang, may idea ka na kung ano yung diameter. Humihina yung velocity, di ba? Ano mangyari ngayon sa diameter? Yung discharge parehas. Humihina yung velocity, lumalaki yung diameter. Ganun yun. So, ibig sabihin, ang sagot kung, actually, nung ako nito, hindi ko maisip yun. Solve. Ano yan? Discharge yan. Q1 equals Q2. Dapat mas malaki yung diameter at point 2. Dahil parehas yung discharge. Yung velocity naman at point 2 at maximum height yan. Yung velocity at maximum height, wala yung Y. So, meron lang yung X component. Di mas maliit yung velocity. So, mas malaki yung diameter. Ganyan. Yung hula na ako, tumama din naman. Isa lang yung...
Malaki siya, sir.
Mas malaki yan sa 75. Okay? So, ang solusyon yan is Q1. Q equals area 1 V1. No? Yun lang. Q equals area times velocity. Yung Q1 equals, meron akong makuha. Yung Q2 equals to Q1. Ang kailangan ko lang i-solve para dito is yung V2. Yung V2, in this, since maximum height, yung V2 equals V2x. Right? And sa projectile motion, hindi ba, walang acceleration sa horizontal. So, ibig sabihin, okay, ang x, lahat ng x component ng velocity, mapa 0.1, mapa kahit saan, lahat ng x component ng velocity, halimbawa, dito may velocity dyan. Yung x component niyan, practically constant yan kasi there is no acceleration sa horizontal. So this V2x equal yan sa V1x. Do you agree? So ganito lang kadali yung solusyon. Okay? So masolve ko yung V1. Right? Given yung Q, 0.23. Masolve ko yung V1. So I can solve V1x. V1x is ito yung 30, V1 cosine 30. Right? So, V2x equals to V1x. V2x equals V1x. But what is V1x? V1x equals V1 cosine of 30. So, I have the V2x equals to V2, the discharge at point 2. And Q1 equals Q2, no? Solve ang area 2. Right? Q1 equals Q2 and V2 is 45.08 equals to V2x. So 0.23 is pi d squared over 4 times 45.8. So solve yung diameter 81 meter, 0.081 or 81 mm. It is more than 0.75 meter. So, ganun yun. Ang ganda ng problem. Ginawa to ni Nolido na. Sabi ko, okay ito. No? So, yes. Ang principle lang talaga is Q1 equals Q2. Yung iba dyan is, ano na yan? Projectile motion na yan. Na yung V1x equals to V2x. Then, solve mo yung V2. Area equals to, Q equals to area times velocity. So that is the discharge. Yung pinaka-principle, right? So next is okay. Next is ito yun, mga open flow ito. Okay? Punta tayo dun sa yung may makita kayong submerged flow, basta tandaan niyo lang yung sinasabi ko kanina. Wala akong problem dito na submerged flow constant head. itong mga problem ko na pinapakita is yun sa constant head. So constant yung pressure paglabas. Okay? Ngayon, may isang case naman, paano pag falling head? Okay? Falling head. Falling head. Paano naman pag falling head? Right? Eto. Yeah.
Paano naman pag falling head? Play ko lang.
Okay.
Okay.
Paano pag
falling head? Okay. Falling head. Ano yung falling head? Ito sa hydraulics, may sinasabi tayong head. Ibig sabihin, yung level nung surface is dropping, no? It's changing. Okay. Falling head. I bet you orifice.
So, if a certain
time, nag-drop yung level ng water, any liquid. So, ibig sabihin, so under yan ang falling head. Halimbawa, mag-drop yan. So, pupunta yan sa after a certain time. So, ito yung X after a certain time T. Mag-drop siya. Drop.
May echo, sir.
Ang tawag ito.
Sir, may echo.
This is generic equation, ha? So that, ano yung Q? Yung Q, di ba? Area of orifice. Pwede, in general, is volume. Okay? Over
May echo, sir.
time. No? Cubic meter per second. Tama? Pwede. Volume over time. So ngayon, pag ganito na, falling head, normally, ang source natin is yung time, no? Kailan siya ma-discharge lahat. So, we are solving actually yung time. No? Yung time. Ngayon, tawag na to, time ang solve natin, there should be volume over Q. Di ba? Ngayon, sometimes ang ginagamit sa mga reviewer, nakita niyo gumagamit ng average Q. Q, H1 is a certain level, Q, then H2 at a certain level, then take the average. Pwede rin, no? In terms of average. Pero, pwede rin, gagamitan natin ang, ito yung pinaka-paborito nyo. Gamitan natin ang differential, differential time, differential volume. Right? Okay? And what is your differential volume? Kuha ka lang dito ng differential, differential, ano ito? Differential height. Alright? And meron kang surface area, ES, so your differential volume equals ES, dH. Okay. Kaya your DT equals ES dx
over
over
Q.
q.
Ayan.
Ganyan
Ganyan
yung formula. Then integrate. No? Integrate.
In terms
In terms of height. No? From 0 to time. Then ito from h1 to h2. h1 to h2. Pwede na. Now this q,
Ito is
ito is generic na ito.
This is Q
This is
of
q of orifice. Sometimes q of where. Pwede rin. Ito generic na ito. Okay? So now normally
if
if ES is constant,
here, ES
is constant. No?
What is
ES? Surface area.
Okay.
ES is the surface area. ES is the surface area. Okay? Surface area. Yun yung ES. AS. Okay, surface area.
If
If
ES is constant, what will happen is
integral of 0 to t dt is time equals ano siya? ES integral of dx.
Di ba?
Diba? Integral of dx. But etong q, if this is q of orifice, ito is integral of dx over q. But yung q of orifice, ito siya. Yes. Then the integral of what is yung q of orifice? Diba ito is CEO square root of 2g. Ito is dx. CEO square root of 2g. Square root of 2gx. So pwede ito time t equals es. Then pwede kong ilabas yung es. Es over c AO square root of 2g. Tanggalin ko yung yung x itaas sa taas. Magiging ito. H2 negative 1/2. Negative 1/2. Negative 1/2. Then dx. Okay? From h1 to h2. Ayan. Etong dx ito is decreasing sa time rates. That is decreasing. So meron ka dapat negative ito. dx dt is negative.
So you can
So
change
you
the
can
limit
change the limit from
maglagay ka
ng negative dyan.
lagyan mo
Lagyan mo lang
from
from
H1 to from H2
from H2.
Baliktarin mo lang
from H2 to H1. Parehas lang naman yung ano. Okay? So, ang nangyari niya, merong tayong formula time equals the integral of h raised to negative 1/2 plus 1, then of course 1/2. No? Negative 1/2 plus 1. Okay, so 1/2, then over 1/2. So magiging ano ito? Over 1/2. So this will be twice ES. Di ba? Over C area of orifice square root of 2g. The limit is ano ito? Magiging h raised to 1/2 square root of h. Right? Square root of h. Then 1 is natin h1 minus square root of h2. Ito yung formula. Ito yung formula nung time. So ngayon, if AS is constant. Ngayon, if AS is variable,
there is no other formula kung hindi
itutuloy mo yung integration. Gagamitin.
If
AS is not constant, convert AS in terms of H1 or H2. Or in terms of H, kasi naka-DH ka. So, kasi halimbawa, pag hemispherical bowl, halimbawa, ganito, hemispherical bowl, lumabas na ito sa ano, tapos kailan ma-drain yung tubig, no? Yung surface area is variable as the time elapsed. So the surface area is changing. So hindi constant. There is no other solution. Instead, okay, use this one. Pero ang pinaka-common sa board exam is constant area, kaya you can apply this directly. Time is twice ES C
over
over
C
C area of orifice square of 2G. No? C is coefficient of discharge. No? Coefficient of discharge. No? Discharge.
Yes,
Yes,
discharge.
Then
AO
is
is
area
of
of orifice. Okay? Area of orifice. Is
area
area
of
of orifice.
So, ganun lang. Pagdating sa
Direct substitution. Okay? Direct substitution.
Okay.
Sir, di makita ang bandang kanan.
Ay, hindi ko.
Yun. Yan, sir. Okay na.
Okay, so tuloy ko lang dito. Mahirap pag walang sulat. Eto. This is ano siya? Small orifice in area. So 0.003 in area, square meter area in the vertical side of a rectangular tank. The horizontal section of the tank is given. So constant area. Madali lang ito. Kasi constant area, 0.4. Given at a given instant, the head of the orifice is 1.2. And 312 seconds later, it is 0.6. Actually, this is possible exam. Compute the value of coefficient of discharge. Coefficient of discharge, C. Anong situation dito? Given at a given instant, so given instant, the head of orifice is 1.2. Okay. And 0.6 meter in 312 seconds later. Ayan. Ano na ito? Direct substitution lang. Doon sa formula. No? Yung twice of ES over C squared of area of orifice squared of 2G. Okay, over C square, area of orifice square of 2G, and then times H1 square of H2 square of. So, ano lang. No? Okay. So, next na. Area given, surface area 0.4. So, first question is coefficient of discharge. Direct substitution lang. So, titingnan mo, yung area orifice given, ang unang tinatanong is coefficient of discharge. H1 and H2 given. So, this is just direct substitution. Ito mga bonus sa board exam. Okay. Coefficient of discharge, the formula is, ito, 2i of ES, square root of H1 minus square root of H2. Then, C over area of orifice over square root of 2G. Ay, yung formula niya. So, time is given, 312. 312 seconds, H1 given, area of orifice given, G is 9.81, if that is all in meters. So, we can solve coefficient of discharge. And that's 0.62. Alright? The other question is compute the time to drop from 1.2 to 0.8. So it's just knowing the equation. Kung ito yung mga question minsan sa board exam na alam mo yan, situational, tapos minsan binabaliktad-baliktad lang, tapos mga certain condition. Madali lang. Provided na alam mo yung formula. Pag hindi mo alam, mahirap. Pikit na lang. No? Pero, to be honest, anong ako'y nag-review, hindi ko to minimorize ng pilitan. Memorize ko na lang yan dahil lagi kong ginagamit. But, ang ginagawa ko talaga is dinidrive ko dahil madali lang yung derivation. And at least, naintindihan mo kung saan siya galing. Ngayon, ina-apply mo, so na-memorize mo siya, but at least may pang-back up ko, saan galing itong formula ko? Kasi ito hindi naman to empirical, so dinidrive yan. So, pag alam mo yung formula, di wala nang problema. Ito yung mga ano ka lang, substitute ka lang diretso, kuha mo na yung sagot. Okay? Twice ES, square root of H1, H2, C, EO, square root of 2G. Substitute 1.2.8, ES, EO, and C. And that is 0.62. Of course, we will use 6.62 given the certain condition. So then you can solve time T. Should be in seconds. Kasi in gravity mo dito is 9.81 meter per second squared. So ang time ano diyan is should be in seconds. Okay? So it should be in seconds, walang minute, no? Mapa-English or mapa-metric. Time normally is expressed in seconds. Then the final elevation after 240. Of course, it should be maybe less than 0.8 kasi at 200 naging 0.8 kung 240. So final elevation. So H2 ang H2 yung tinatanong. Substitution. 240 twice OBS 1.2 square root H2 ang tinatanong. Then constant C, area of orifice, and square root of 2G. One and on one equation, you can solve H2 0.733. Of course, pwede ka namang hula kasi dito sa first case 202, the 0.8. The 240 more less than 0.8. So 0.733 meter. Right? So yun yung solution. Ito yung pampagana, I believe, sa board exam, no? Na kung saan ang kailangan mo lang is mag-substitute ng ng mga given. Okay, let's move to other problem, yung mga naman tawag nito, yung naiiba naman. Okay, so meron na kayong polling head, so connected, okay, tawag nito constant head. So a special case sa orifice is yung may mga interconnected tanks. Sa nakailang halos yung mga board exam, may mga ganito. Minsan ako nag-board exam, meron ding problem na tawag nito. May board exam na interconnected tanks. Right? So may derivation ito, no? Of course, huwag kayong magdasal, although hindi pa binibigay sa board exam. Dalawang tangke, tapos magkaiba yung surface area. Magkaiba yung surface area, tapos hindi siya constant. Okay? Alam mo yung, halimbawa, hemisphere yung one tank. Tapos yung isa, let us say, frustum, no? Tapos i-connect siya. Tapos hahanapin yung find the time na yung dalawang level magkapantay. Naku po. There is no solution kung hindi ang hirap ng solution. There is no other solution kung hindi time range integral. No? Ngayon, pero pag interconnected tanks tapos constant area, okay lang. No problem. No? Pag interconnected tanks, constant area. Kasi ganito lang yan.
Interconnected tanks. Interconnected tanks. Then, ito special case ito sa sa falling head falling head orifice. Para mapin ko siya. Lalabas yung Ayan. Okay. Okay. Ito special case sa falling head interconnected tanks. Ito binibigay ko sa inyo, ito lang yung mga mga common sa board exam, no? Interconnected tanks. Okay? Ang common lang is, ganito, meron niyang, basta ano lang, ang lumabas so far is, yung, minsan may tube, tapos iba yung surface area. Okay? So, pwede, eto, mas mababa ng kunti. Dapat mas mataas yung isa kung talagang merong flow. Right? So, ito is interconnected tank. Let us say ito is surface area 1. No? AS1. And ito naman is merong surface area AS2. Okay? So, ganito lang mag-memorize. Of course, ito yung edge. No? Ito yung edge. Okay? Yung sinasabi nating edge dito, by the way, yung kanina, di ba ang edge dito should be the difference between the in at saka out. Okay? Ang in dito, it should be this one. Okay? Ngayon, ang out dito should be this one. But it should be the difference between the two. So therefore, yung x na pinag-usapan natin dito, itong x dun sa equation, should be the difference between two. And that is, okay? So this is the initial, kung may movement man dyan, so depende na. Basta x dyan is difference between two level. No? Okay. Considering this is constant, no? Ito constant. Constant. Kasi kung given niya constant. No? So ito are all constant. Constant yan. Madali lang i-memorize. Madali lang i-memorize. Ang formula kaparehas nito. Okay? Modify mo na ito ng konti. Okay? So yung time equals. Di ba dalawang area na? Dito kanina, pag isang tangke lang, isang ES lang. Di ba? Ngayon, pag dalawa na, take the product over sum. So instead na ES, replace ES, what? That is twice of, replace ES, and then twice of C, EO, square root of 2G. Okay? Replace ES, yung ES mo, instead na isa lang, take the product over sum. So that is AS1, AS2 over AS1 plus AS2. What? Twice of ES1, ES2, then, okay, square root of H1 minus square root of H2. So, ito lang siya. So, ano yung pagkakaiba sa formula? Pag interconnected terms, right? Halos kapares lang sa isang tangke, pulling it, right? Yung ES, papalitan mo lang ng product over sum of two surface area. Maliwanag. Right? So, ganun lang ang ano. Ngayon, kung hindi constant ito, then, sorry, kukuha ka ng differential discharge. Babalikan mo yung kanina. Yung time equals d volume over Q. Where Q is a function of height H1. So, and then surface area, a function of yung H. Para makuha mo yung time. But so far, then integrate. So far, wala pa namang binibigay, kaya hindi ko na hindi na ako magagawa ng example na gano'n. Kasi sobrang haba ng solusyon. Sa mga reviewer, merong ganyan, no? But wala pang so far nakita kung good exam na binibigay. Mahaba yung solusyon pag hindi constant surface area. Kaya pag binibigay so far is yung constant surface area, pag constant, no problem. No problem. Ito lang yung konting modification sa formula, then no problem. Okay? So kaya sigurong memorize. No? So, ganun siya. Ay.
Two vertical tabs near the bottom by short orifice with a cross-sectional area of 0.004. Diameter of tanks A and B are 8 and 5 respectively. Water level of tank A is 10 meters above of B. Ito yung difference niya. Difference ng height between A and B. Difference ng level surface. Coefficient of discharge 0.6. Compute the discharge in the orifice immediately after opening the orifice. So immediate. So ano yung ibig sabihin ng immediate? Hindi yan, hindi yan falling head. Immediately. So it's just simply Q is C area of orifice is square root of 2GH. So ganun lang yun. Then time of water surface na at the same level. How many times, how many minutes will the surfaces be 4 meters apart? So yung number 1 is just simple application sa formula. No? So we have here area 1, area A and area B, no? In terms of pi, area of orifice 0.004. Ito yung mga given. Yung H1 10, and then sandali, bakit ito 3.2? Okay. So mali ata yung H2. Hindi kasama tong iba, ba't may given? Ito yung wala ito. Okay, wala yan. Okay. 0.6. Tama, 0.6 ba yung ano? Wala. Yes, 0.6 is the coefficient of discharge. Okay? So, yung H2 ang ano. Ngayon, ang unang question is immediate, di ba? Compute the discharge. Ayan. Compute the coefficient, compute the discharge. I'm sorry. Compute the discharge in the orifice. So, Q. Immediately after opening. So, yung ano niyan, kasi immediately, hindi pa nag-change yung height. So, itong first case this is the case of constant head, immediate. So, constant pa. Hindi pa nabago yung water level. Discharge at time equals to 0. So, ang formula dyan, yung discharge, ganun lang. Q is C area of orifice, square root of 2GH. C is 0.6, area 0.004, height is 10 meters, then Q is, ito siya, this is 0.0336 cubic meter per second. So yung pangalawang tanong naman is, ano ba yan? Time for the water surface is in the same level. Okay? So mag-level siya. So, di ba may formula tayo? Ano yung formula? 2 ES1 ES2 C area of orifice square of 2G times AS1 plus AS2. Di ba? So, anong kulang dito sa formula ko? Yung kulang ko is times area of orifice. Okay? Kin ko lang konti. Times area of the orifice. Okay? Wala yung area of orifice. Okay? So, substitute. Ang problema lang actually is ano yung H1, ano yung H2. Okay? Yung H1, di ba, sabi ko kanina, yung H should be difference between the height between the surface. Yung H1 ko is 10 meters, di ba? Makita mo dito, yung level niya is from, okay, eto, then sa yung isa is, yung isang tangke, and that is 10 meters as per condition. So that is your H1. Ngayon, pag same level na yan, ano kayang mangyari? Kung siguro nandito banda yon, no? Same level. Okay? But if the same level na, ano yung H ngayon pag the same level? Right? Of course, yung H2 ko niyan equals to 0. Kasi wala na siyang head difference. So yung H2 ko is 0. So yung H1 mo is 10, H2 is 0, and you can solve the time. So that's time elapsed na ang ano is the same level. So kulang pa ito ng area of orifice, no? Times 0.004, and that is ano, time equals to 8,400.2 seconds. So yan yung time. So in minutes, kung converts in minutes, in hours, pwede mong i-convert yan. So if in second, depende lang sa choices. Basta answer for this, the equation, if you're using 9.81 meters, and this should be in seconds. Time should be expressed in seconds. So time for the water surface, 4 meters apart. So ibig sabihin, yung H1 is 10, yung H2 ngayon is 4 meters. Kung sinasabing 4 meters apart. So ganun lang is for this problem, it's just an understanding of what is the H1 and what is H2. So ano lang ito, actually ito nung lumabas ito, parang bonus na rin kasi this is just direct substitution. So H1 is 10, H2 is 4, area 1, area A and area B is given. Then ayan, ano lang siya, direct substitution. So 0.004, yun yung area of orifice. Yun yung nawala sa equation. Right? So you have a time equals 3,087 seconds, 0.4 seconds. So depende lang sa choices kung nakabe minutes or in hour. So in seconds, that is 3,000. Mas matagal, no? Ngayon, so ano yung mga tinitingnan natin dito? Basta kung kailangan natin yung discharge. Okay? Kailangan lang naman natin is yung yung height, yung head. O ano ba yung head na yon? Is ito yung yung available, yun yung height of water above the crest. Yung sinasabing crest, ito yun, no? Yung level, ito yung crest na sinasabi, ito yun. From this level, yeah, kaya yung height of crest or yung plate, yung weir plate is yung P. Yung head niya is yung H. Ay, yung head, yan lang yung nagdadala sa yung discharge, yung kung mas malaki yung head, di mas malaki yung discharge. No? So, meron yang sa side view, it can be rectangular, no? It can be triangular, no? It can be trapezoidal. No? So, ganon. May yung iba nga, parabolic. But I will just show you yung tatlo lang yung pinaka-common sa exam. Triangular, rectangular, at saka trapezoid. Yung trapezoid, pinag-combine lang naman na tawag nito, rectangular at saka triangular. Okay. So, yung formula, this can be derived from area times velocity. So, pwede itong ma-derive, pero medyo mahaba yung derivation. I'll just give you the summary. No? Okay. So, yung summary ng equation, ito yan, yung types. Triangular, rectangular, at saka trapezoid. So, yung if yung C is given, generally less than 1, ito yung general formula. The equation for triangular is, ito siya. 8/15C, square root of 2G, tangent theta, over 2. Okay? Times H raised to 5 halves. O, saan yung H? Yung H is, ito yung head available. No? So, yung H is this one. Ito yung H. Right? So, ito yung H. Okay? Yung theta, of course, yung theta naman is, klaro naman yan. No? So, yung angle theta. Okay, yung angle theta. And, mapapansin mo sa equation, ang naglalaro lang dyan is yung theta at saka yung H. Di ba? Ngayon, kung rectangular naman, ang niya is 2/3 C square of 2G. So, nabawasan yung instead na H/5, H raised to 5 halves, nagiging 3 halves. Tanggalin mo yung isang H, palitan mo yung L. No? So, ito, naging 3 halves na lang instead of 5 halves. 3 halves, 1.5. Dito is 2.5. So, tinanggal yung isa. So, Pero papalitan mo ng L. So L times h raised to 1.5 or 3 halves. So, yun yung rectangular. Alright? Then pag trapezoid, normally, ina-add lang siya. Rectangle at saka triangle. So, combination ng A and B. Now, pero may special case ito. No? If C is not given, normally, by the way, yung C na pinag-usapan na, what is C? C is, okay, coefficient of discharge. Right? Discharge. In this case, normally, C normally less than 1.0. Okay? So normally C less than 1.0. But if C is not given, okay? If C is not given, triangular, no? Automatic yan, use 1.4. If C is not given, use 1.4 for triangular, okay? 1.4 raised to 5 halves. Itong 1.4 na yan, actually yan yung yan yung equivalent ng, okay, 8/15C square root of 2G tangent theta over 2. No? So use 1.4. Now, if rectangular, no, ito yung pinakasikat sa lahat na ginagamit in most design. Kahit sa project nyo siguro, kung meron kayong makita nyo, Francis formula. No? Okay? 1.84. Ito yung pinaka-common na ginagamit. 1.84 LH raised to 3 halves. Now, pag trapezoidal, ito yung kay Cipolliti Weir, 1.859. No? 1.859 L raised to 3 halves. Okay? Kaya kung mapapansin nyo, okay, 1.4, actually ina-arrange ko ito para mas madaling i-memorize. 1.4, 1.84, 1.859. Di ba? I-arrange nyo lang, triangular, rectangular. Ngayon, ito, 8/15 square of 2G. Actually, ano yan? 2. Tawag ito. By the way, yung Cipolliti Weir, applicable lang yan pag ang side slope 4 vertical, 1 horizontal. No, yun yung kay Cipolliti. In-experiment niya kasi yan, yun yung slope. Approximately yung C at 0.60. So lumalabas yung coefficient niya 1.859 kay Cipolliti Weir. Pag makita niyo sa problem na side slope 4:1, automatic yun, use this Cipolliti Weir 1.859. Kahit trapezoidal yan. Okay? So 1.859, then 2.36. 2.36 yan yung 8/15 square root of 2G. 2 square root of 2G. 2 times square root of 2G, I'm sorry. Z is 9.81. And 2.95 pag 2/3. Ayan. 1.4, 1.84, 1.859, ano pa, 2.36, and 2.95. Okay? So, yun yung Ngayon sa tawag ito, consider tayo sa rectangular. Sa rectangular, okay, meron niyang L. For rectangular, yung L na nakalagay dyan sa formula, it should be yung corrected L. Yung L, corrected. Bakit corrected? Kasi, minsan, okay, kung balikan natin, wala lang dito. Okay. Yung sa pakipin na lang yung isang, kaya nyo magawa sa view nyo na pinipin nyo yung yung isang camera, pagkatabi yung naka-share para makita nyo. Para hindi ko na galawin dito. Okay.
Okay. Ito yun. Paano na lang ha? O rectangular. Meron kasi tayong contractive weir. No? Or rectangular weir. Meron kasi tayong ano, yung side view ng rectangular, no? Ano ba ito yung ano niya, weir plate. Assume ito yung weir plate. Then ito yung flow, no? Ito yung edge. Okay. Then sa gilid, okay. Ito yung ano niya, ito yung tsura. Okay. Then ito yung L, no? Diba yung L? Okay. Pwede kasi two end contracted. Yan. Pwede kasi ganito. Ito yan. Ito yung tubig. Ito yung tubig. So, pag lumalabas yung tubig dyan, so may kunting kunting contraction. Okay. So, hindi ito yung L. Sorry. Kung ito yung width of channel. So, pag sinasabing suppressed weir, yung weir na ito is parehas dun sa width of channel. But sometimes, yung weir mo is, ito lang yung length ng weir. Okay? So, yung sinasabing L dun sa ano, it should be corrected. Ang tamang L dyan, yes, ito. Okay. Ito yung L na sinasabi. Okay. L prime. Sorry, this L prime. So yung L prime equals to L. So kung ito is H, no? H. This is minus, no? Ano ba ito? 0.1. Okay? N H. Okay? Where N equals 1.1, no? 0.1 for 1N contraction equals 0.2 pag 2N contraction. Ayan. In this case, kasi ito kasi yung ito yung correction eh. Halimbawa, ito 1N. Ito na lang. Ilihiwalay ko na lang. Okay? Ito yung 1N na sinasabi. 1N contraction. Okay? So, ito, then, ito na siya. Okay? This is a case of 1N contraction. Halimbawa, yung tubig, pasok ng tubig yan. Dala pa ng tubig. Mangyari kasi is itutulak niya dito, gagawin siya. Kaya yung effective, yung paglabas, ang effective L, eto lang, L prime. So kung ito is L, so yung L prime dito, L prime equals to L minus 0.1 of H. This is the case of 1N. 1N contracted. So 1N contracted. Ito 2N. Ito 1N. So one side lang. Okay? So mangyari kasi ipupush niya dito sa gilid eh. So effectively, so parang liliit yung width nung nung weir. So parang gano'n. So in case of rectangular weir. Meron pang special case niya na pero kino-consider may yung velocity of approach. Pero konti lang yung diferensya. So just always neglect the velocity of approach. Kung channel naman yan, hindi ano lang naman siya. Okay? Yung spillway, normally neglected yung velocity of approach. Yung paglabas ng tubig dun sa ano lang siya, smooth flow. Okay? Pwede siguro kung mga bagyo, no? So mas mabilis yung flow. So merong consideration of velocity of approach. But basically, Ang sa application, may mga time breaks, ito lang siya, hindi na kino-consider yung velocity of approach. Correction naman yun dun sa head, no? If mabilis or mabagal. Okay? Pero ang pinaka-ano lang is itong pinaka-basic na equation. Rectangular weir, 1 in contraction, 2 n. So 0.1 or 0.2 of yung correction. 0.1 or 0.2 of h. Okay? Sa constant head analysis, madali lang kasi doon ka lang iikot. For constant head, ito lang mga equation na ito. Right? Sorry. Kalimutan ko.
For constant head, dito ka lang iikot ka lang sa anim na equation. Pag falling head, ito lang din siya pero ano na integration. Okay? Bawa etong problem. Ang daming mga problems sa board exam na direct substitution lang, no? Weirs. Halimbawa, sharp-crested weirs has length of 5 times its head discharge. Ito mga past board exam ito eh. Compute the length of the weir. Ito yung mga bonus sa board exam. So, given Q, given CD, so gagamitin mo dito, rectangular. Yung 2/3. Di ba? Yung 2/3, C square root of 2G. Then L, H raised to 5 half. Okay? So, direct substitution lang. Direct substitution lang. No? Eto. L is 5 halves. Q is 3.25 cubic meter per second. CD 0.8. So, yung formula, Q is 2/3, C square root of 2G, L raised to 3 halves. Find the length of weir. Then given Q, given L in terms of H, you can solve H in one equation, one unknown. Then after solving H, multiplied by 5, you can solve the length of the weir. Di ba? Ano ba yan? L is raised to 5 halves. Ba't nandito yung L ito? So, then, check na natin. 3.25 divide 2/3 divide 0.8 divide 2 and 9.81. Okay. Divide 5 5/2. Okay. So, x square 5/2. 2 divide 5. Okay, H is 0.596. Okay. H is 0.597. All right. So here, so H equals 0.5968. Okay, meter. Okay. Then L equals to 5H. Therefore, this is 5 times 0.5968 meter. So you have 2.998 meter. Okay? So times 5, 2.98. 2.98 meter. So far sa mga ito, wala akong problema ito. Is basic kahit pikit yung mata nito, magkakasolve nyo ito. Kunting kunting familiarization sa equation, no? Okay, so etong kasunod na question is ganun din, constant head. Halos mga ganito lang so far na binibigay, lalo na ngayon. Yung problem question sa hydraulics, minsan umabot ng 75. Buti na lang minsan 50 lang yung binigay ni Estanyero. Okay? Kung 50, di marami-rami yung marami yun. So normally, yung mga problem hindi ganoon kahirap. So yung mga direct substitution. Ano bang suppress weir? Ito yung sabi ko. Suppress rectangular weir. By the way, ano yung suppress rectangular weir? The suppress rectangular weir That is, ang ibig sabihin niyan, the width of the width of channel, kung ito yung channel mo, okay? Ito yung channel mo, yung kanal mo, okay? Nilagay yung weir, sakto. Sumakto lang yung ano, halimbawa, yung kanal mo, yung weir mo is, sakto siya. Equal, equal yung width nung ano, yung width nung channel at saka yung length nung weir parehas. So yun yung sinasabing suppressed rectangular weir. Yan yun. So again, ibig sabihin the width of channel equals length of weir. Ayan. Yun yung suppressed rectangular weir. Direct substitution. Merong C given 0.62. The same formula. No? So, Q is 2/3 C square root of 2G. L raised to 3 halves. So, direct substitution. Actually, ito mga past board exam ito. No? Napakita ko lang sa minsan. Yun yung mga board exam na minsan may mahirap, na minsan kadalasan is mga madadali lang, no? Okay? 2 steps, 3-step solution. Okay, punta tayo sa ano? Doon sa falling head. Kasi ito constant. Pag constant, diretso lang, no? Direct substitution. Minsan pwede itatanong dito. Find the total time na to discharge a certain amount of water. I-equate mo lang ito sa Q equals volume over time. Kung constant head, kung may volume ka na given, i-divide mo lang ng discharge, meron ka ng time. Di ba? Punta tayo sa ang falling head medyo may konting tricks dahil na yun, kumbaga integral. Ito si Politi, constant head. Diretso lang din ito. No? So 1.859 L raised to 3 halves. So, medyo direct substitution lang. Ito yung mga bonus na lang yan. For this just familiarization, yung formula kanina, no? Punta tayo sa iba. Ito madali lang to. Punta tayo sa falling head. Ano bang ibig sabihin ng falling head? Katulad kanina sa orifice, yung surface area is changing, no? At a given time. Okay? So, but yung formula ng weir, parehas lang. Yung 1.84, 1.4, 1.8, depende sa type of weir. Di ba? Ngayon, paano naman yung diskarte natin pag falling head? Ito na siya.
Di ba? Sabi ko, papina lang yung isang kasi makontrol naman yung view itong sa blackboard. No? Pwede nyo side by side try nyo side by side yung itong sinishare at saka yung mag-pin kayo ng yung video ko isang camera. Yung camera nito. Tapos hatiin nyo sa dalawa. Pwede nyo i-drag yung side by side na video. Tapos i-pin yung itong sa view na ito para makita nyo dalawang view sa screen. Okay. For falling head, falling head. Parehas lang yung equation kanina. No? Ano ba ito? Weir. Okay. Weir. Rectangular. Pinakakuha mo naman talaga sa rectangular weir. So, number ito yung weir plate. No? Ito weir plate. Tapos, yung tubig, ito, So yung head, di ba? Ito yung head. Ngayon, tapos ito yung permanent crest. Okay? Ito naman is weir plate. Okay. Yung plate, weir plate. P. Ayan. Okay. Pag pulling head, so ibig sabihin, at a given time, the height of this is changing. Na? Pwedeng mag-increase or mag-decrease. Ngayon, anong formula? Yung formula natin, parehas lang kanina. Di ba? Meron tayong time. Okay? Ano yung kanina? Time equals? Okay? The integral of volume over Q. Now this time, this is Q of Weir. Di ba? So ano yung volume? So this is actually the volume. Di ba? Ito yung ano kanina? ES dH over Q of Weir. Kanina is Q of orifice. Okay. Ano lang, ganyan lang. Ito yung generic equation. Right? Ito yung generic equation. And generic equation. Okay? So, of course, kung ito yung H1, tapos mababa yan, nagiging H2. Yung H natin is galing yan sa weir plate. No? Papunta doon sa taas. Kasi head ang pinag-usapan, hindi naman total depth ng channel. So, it should be head above the weir plate. So, this should be from H1 to H2. Okay? Now, ngayon, masunod tayo. Okay? Minsan, not minsan, most of the time, this AS is constant. If AS, okay, is constant, constant. Okay? So yung time is AS, then square root of integral of dH over Q ng Weir. dH over Q of Weir. Halimbawa, for rectangular, triangular, trapezoidal, depende na lang doon sa given. Okay? Now, sir, meron bang tawag ito? Yung mga derived formula. Meron ba tayong mga formula katulad yung kanina doon sa orifice na yung twice ES square root of 2H1 H2 minus H2 over CEO square root 2G. Dito sa orifice, sa Weir, wala tayong ganun. Dahil magkaiba yung Q ng Weir. Iba yung rectangular, iba yung trapezoidal, iba yung what? May iba't iba yung Q. Unlike kanina sa orifice, yung Q ng orifice, isa lang. C area of orifice, square root of 2GH. But dito, walang ganon derived equation. So, dito ka lang iikot. Pinaka-end mo is hanggang dito lang. ES, square integral of dH over Q of Weir. No? So, ganun lang ang wala tayong formula na wala tayong formula, derived formula para sa Weir. Na, kumbaga, to solve yung time, tapos falling head. So, ano lang talaga yung generic equation, T is ES, then integral dx over Q of Weir. So, yun lang. Okay? Now, itong problem ito. If you try to scan yung mga past board exam, makikita nyo ito, ulit-ulit, no? Yung ganito. Okay. Spillway, 11.86 meter long that is used to control reservoir area of 5 hectares. So, ito yung mga ginagawa ng mga nasa sa irrigation, NAIA, National Irrigation, okay, Administration, yung mga sa palayan. Permanent crest elevation 75. Find the time required to lower the water elevation from 76
0.5 to 75.5. So 1 meter drop. Use Francis formula. Ayan, use Francis formula. Sige nga, paano? E di, ito lang yung formula niya kanina. So, ito yung tawag nito, yung permanent crest elevation at 75. Ano ba yung sinasabing permanent crest? Yun yung tawag nito. Ito yung, kung spillway yan, yung top nung spillway. So yung head mo above the crest is 1.5 and it's dropping to up to 0.5 kasi from 76.5 to 75.5. So after certain time, 0.5 na lang yung head mo. So from 1.5 to 0.5, 2.5 meter head. So H1 is 1.5, H2 is 0.5. So ang tanong, kailan or ilang minuto, ilang segundo na ang head available is only 0.5 meter sa spillway. So initially, that is 1.5 meter. So ngayon, there is no formula actually. Except yung formula ng Francis. But formula to solve yung time, wala tayong ganon. Integration talaga ito. Sir, hindi ba pwede yung formula na T equals volume divide Q? This is only applicable if your Q is what? If your Q is constant. Now, since your Q here is varying, bakit varying yung Q? Yung H mo is nag-drop, nag-change. So, hindi pwede. So, gagawin natin is yung integration, yung sabi kong formula na, integral of, okay, d volume over Q, from H1 to H2, where Q is, use Francis formula, 1 point, okay, yung Q ng Weir, 1.4 L times H raised to 3 halves. But yung d volume natin dito is, ang itong kagandahan, okay, itong kagandahan. Kasi yung differential volume, ito yon. Ito yung differential volume. So, ES times, ES times differential, ES times differential height. Okay? So, yun yung differential volume. Kukuha ka lang ng, yung surface area mo is constant. No? Kung ano yun, that is ilang hectare? 5 hectares. No? So, 5 hectares yung surface area. So, that is, halimbawa, ito, papunta doon. Okay? Kung reservoir, so 5 hectares. Okay? 1 hectare is 10,000 square meter. So, ES here is constant. So, pwede ko ilabas yung EH. Pero by the way, ito lang talaga yung daanan mo pag solve yung time tapos falling head. Kung ang ES mo is hindi constant, there's no way, kundi express ES in terms of DH. Pero normally kasi constant, so far binibigay sa board exam, so pwede mong ilabas yon. So simplifying further, so 1.84 L, kasi ito Francis ito yung Q, 1.84 L H raised to 3 halves. Then, tawag ito, ES given 5 hectares, L is given 1.86. So ano na lang dito ang variable? Yung H na lang. So naka-DH tayo. So pwede kong iakyat itong H. So magiging ilabas ko itong ES tapos 1.84 of L. Tapos yung H raised to negative 3 halves. No? Tama ba? Or pwede ganito na lang. Pwedeng ihayaan mo lang tapos i-integrate mo na. No? So actually pwede mahirapan yung calculator. Ang dito is iakyat mo talaga yan sa taas. Ngayon, bakit ko nilagyan ng minus DH? Okay? Bakit minus DH? Kasi ang limit ko, look at the limit from H1, no? 1.5. Yung H2, 0.5. So meaning yung height ko is dropping. So the rate of change of height is decreasing. DSDT kasi ang original kasi ito DHDT ito eh. Yung change of kasi initially DT, di ba? May DT dito. Tapos in-integrate na wala na. Yung DH natin, lagyan natin ng negative sign. Ngayon, kung ayaw niyong lagyan ng negative sign, i-reverse mo yung limit. So from 0.5 to 1.5. Pero in reality, ganito talaga siya. So from 1.5 to 0.5, pero yung DHDT mo, yung DH should be lagyan mo ng sign. Kasi ito time range ito eh. Okay? So minus negative. Okay? Then, kaya na pwede na kunting twist. O yan. 50,000 1.84 times 11.86, then h negative 3 halves. O, di ba? Ayan, pwede na. Pwede ka na mag-stop dito kung ayaw. Pero u to the n lang naman ito eh. No? U to the n, integral. U to the n plus 1 over n plus 1. Okay? Then, yan, substitute. You can solve the time. You calculator, you can do it, no? Kunin mo yung constant, 50,000 divide 184 and 11.86. Tapos pwede mong isama yung negative. So ang ending yan, pag i-integrate mo ito, magiging magiging negative. No? Tama ba? Meron itong calculator na yun. Hinahanap ko yung sa Canon eh. Ang problema, may bayad pala. Kaya tinatry ko yung mabigyan ako ng isang kilala ko sa Pilipinas. Ayaw magbigay. Anyway. Yung electronic. Okay, so u to the n lang naman ito. So h raised to negative 3 halves plus 1. So h raised to negative 1 half. So ang ending niyan is ganito. Ay, wala. Anyway. Ang ending nito is h.
Sir.
2,739. 2,739. No? So, ayan. Yeah, 2,739. Ngayon, ganito kung mawala kayo, basta tandaan nyo lang, ito yung concept. Minsan kasi, baka hindi nyo nalagyan ng negative, negative yung time. There is no negative time. Just take the absolute. Okay? But sometimes, malilito kapag hindi mo may pasok yung negative na yan, tapos yung final head yung hinahanap, doon na ngayon magka-problema. So, in theory, dapat sundan mo talaga yung limit. Limit mo is pag nag-decrease yung height, then lagyan mo talaga ng negative yung DH. Kasi may problem na time range ito eh. So, pwedeng initial, sinasabi, at a certain time, nagiging yung 0.5, tapos tumaas yung tubig. Eh di positive yung DH. Di ba? So from H2 to H1. Eh dito is from H1 to H2. So ganon. So lang, basta kahit anong type ng Weir, tandaan nyo, pag ito time rates, dito ka lang iikot sa formula. Ito lang, tandaan mo lang yung concept. Ito siya. D volume over DQ over Q. So general yan dahil unang-una magkaiba yung formula ng Q ng Weir. No? So wala tayong, kahit saan nyo tingnan sa mga libro, walang derived formula for a falling head under this topic. Meron lang tayo yung generic, D volume over Q. Yan lang. Then the rest, halimbawa ito. What is the final elevation? Ito halos baliktaran lang ito nung nauna, di ba? What is the final elevation? Given yung surface area, initial head, given, permanent crest elevation, given. What if the water release at 0.7 hour? What is the final elevation? Etong previous, ang hinahanap is time. Ito naman, ang hinahanap is final. So H2, given yung time in 0.7 hour. Ngayon, eto tandaan nyo, pag hindi sinasabi, kahit hindi sinasabing anong klaseng weir ito, spillway. Di spillway by default parang rectangular 'yon. Yung mga gate, halimbawa, bagat dam, kung ano yung spillway 'yon. So, ang Q noon, paano lang, 'di ba? May pag mag-ulan, kino-compute na lang discharge. So, ano lang 'yan? Length nung weir na 'yon, no? Yung length nung spillway, kung ano yung head pag open ng gate, ay mako-compute yung discharge. Ano yung final elevation? given the water release in 0.7 hour. So actually ito din yung formula, no? Ito din yung formula ginagamit ng mga nasa ano. So eto kabaliktaran lang. So find x or h2 given yung h1 1.5, permanent crest is 64, L is 11.86. So kabaliktaran lang actually, no? So ayan, D volume over Q. Time is, what is important here is, when you use the time in the equation, this should be expressed in seconds. Okay? It should be expressed in seconds. Do not use that in hour.
Always yan, sir. Seconds.
Always yan, seconds. The reason is, ito mga 1.84 LH raised to 3 halves, ano yan? That is in cubic meter per second. So yung time, it should be in seconds, no? Lahat naman halos sa application sa it should be in seconds. Kahit yung mga motion problem na kasi may gravity tayo, meter per second or it can be feet per second. So yung time it should be in seconds. So in this problem, find h2 or x. So eto siya. Yung 0.7, that's equivalent to 2520 seconds, no? 0.7 times 3,600, that is 0.7 2,520. 2,520 seconds, no? 0.7 times 3,600, 2,520. Ngayon. So area is 46,000 and find h2. So you can what? You can simplify this to kung i-integrate nyo, ito, ilabas yung constant integral of h raised to 3 halves. So you have, okay, so wala akong so ang ending niyan is, ano yung integral ng h raised to 3 halves? Di ba, 3 halves, negative 3 halves plus 1, so negative 1 half. Then ang answer nito is h raised to negative 1 half over negative 1 half. Di ba? So, anong formula nito? Anong formula nito? Dito ko na lang isulat. So, isulat. Na-pin nyo yung nagawa nyo yung side by side. Pin yung isang camera. Tapos yung isang is yung sa sinishare. Bali dalawa lang yung sa screen lalabas. Nagawa niyo sa sa laptop. So yung formula niyo yung 2
Sir,
5.
hindi namin makita, sir. Malayo.
Ay, hindi makita. Ulit. Hindi yung view sa view tapos side by side kasi control niyo yung yung view ng 'di ba naka-share screen ako sa tawag nito, naka-share screen ako dito sa yung PowerPoint. Gawin nyo yung view hatakin nyo yung tapos side by side makita nyo yung sabay. Anyway, ito na
Okay,
lang.
sir. Okay.
Pwede nyo lang. Ay, hindi nyo lang. Anyway, turuan lang kayo later. So, 2, 5. Ano yan? 2, 5, 20 times
Okay, sir. Noted. Ang galing, ha.
11.86. Okay? Over 46,000. 46,000 equals negative ito. Negative DH. So, ano yan? H raised to negative 3 halves. So, this is H raised to 1 half. No? Over, ito na lang. Over negative 1 half. Di ba? From H1, from 1.5 to X. Ayan. So, yun yung equation. So, you can simplify this. No? So, this is whatever be, minus times 2 ito. Tapos may negative dito. Kasi may negative. So, di ba may negative 1. So, mag-cancel yung negative. So, bali, ang mangyari nito is 25, 20 times 1.84 times 1, 11.86 divide 46,000. So, this is 1.195. Ayan. Then, equals 2. No? Then times 1 over square root of square root of x minus 1 over square root of 1.5 and solve your x. So you can solve x. So ganun lang siya. Right? Again, there is no formula exactly. No, yung x nito is 0.5 meter. So dito ka lang talaga iikot sa yung formula nung time equals d volume over q, then integrate mo. So magdidepende siya doon sa kung anong type of weir. No? So the final elevation equals to 64 plus x, so 64.5 meter. So this is the final elevation of the water surface. So after 0.7 r, no? Or 2520 seconds. So yan. So no, eto iba naman yung ito rectangular weir. Tapos ano ba ito? Rectangular to. Spillway is also rectangular weir. Ito naman is rectangular weir. Length of 1 meter is constructed at one side of the large tank with cross-section of 20 by 20 and a height of 10 meters. The initial head is 1 meter. Determine the time it takes to discharge 72 cubic meter of water. Use Francis formula. So, yes, Francis formula paggamit. Sometimes may board exam binigay nito, halos ganito siya, pero yung weir is trapezoidal weir. Minsan, may isang board exam, triangular weir. No? So, depende. Kaya, wala siyang general formula na talagang derive siya na, So, kailangan i-integrate mo talaga siya. So, ganito siya. Determine the time it takes to discharge. No? So, ngayon, may dimension 20 by 20. So, maliit lang to. Hindi to siya large reservoir. Unlike sa pag sobrang, let us say, spillway. No? Large watershed. Tapos may spillway. Halimbawa, nung lately lang may bagyo. Kahit na 5 gate yung i-open ng Magat Dam or hindi ganoon ka after 2 seconds, 3 seconds, bumaba agad yung water surface. Hindi ganoon. So, ibig sabihin, that is a large area. So, yung to solve the time, it's just simply Q over volume. Solve mo lang yung Q. May volume ka, 20 by 20 by 1. Pwede. Hindi ka na mag-integrate. Pero ito, 20 by 20, sigurado mag-drop yung height niyan. Instead na 1 meter yung initial, after maybe mabawasan ng 72, hindi na yan 1 meter yung head. So this is the case of falling head. Falling head, tingnan natin Okay, ganito siya. Initially, 1 meter siya. Ngayon, nung nabawasan ng 72, 0.82 na lang. Paano yan kinakalculate? So initially, yung volume ng water above the permanent crest is 20 by 20 by 1. So that is 400 cubic meter, right? Nung binawasan ng 72, na-release yung 72, ilan na lang? Di 400 minus 72. Di ba? So ilan yung ano na yung natitirang height? Di yung difference, divide mo ng ano, yung area. O, di ba? So, ganito lang siya. Volume is EH, then volume is 72, 20 by 20, no? Times height. So, yung 72 na yan, yung nawala, yan yung nawala, yung height na ito, is ito yung na-release. Ito yung decrease or change, 0.18. So, therefore, yung final head is, instead na 1 meter, 0.82 na lang. So, ito yung the case of falling head, dropping head, changing head. O, di ba? Eh di, gamitan mo yung formula. Yung time is integral of dH over Q ng Weir. And that is, yung Weir mo is Francis formula, 1.84. O, di ba? Ito pa rin yung gamit mo. D volume over dQ. Yung volume mo, the volume is ES times dH. Kagandahan nito, yung ES mo is constant 20 by 20. O, yung Q ng Weir is, ayan, 1.84. Pres kanina. Basta dito lang dito sa problem ko puro mga France, ito kasi yung pinakasikat eh. But it can be triangular, it can be trapezoidal Weir. Parehas lang yung yung L at saka H lang naman ang mag-change diyan, yung coefficient. But the principle is the same. So find time to change. Okay, from 1 to 0.82, yung parang katulad lang kanina. Yung ES mo is 400 DH, then akyat mo yung 3 halves, raised to 3 halves. Okay? And raised to negative 3 halves, may negative. Then, pwede mong i-this calculator kung meron kang yung gandang calculator, no? You can solve time 45.35 seconds. So, yun yung application sa falling head weirs. Okay? So, ganun. Ano pa? Weirs. Yun lang constant, then falling head weirs. Ilang naman lang lagi na-encounter sa board exam. Okay? So, yun lang. Ang kailangan naman dito is familiarize yung equation ng weirs. Then, constant, madali lang. Ang mahirap is yung falling head dahil there's no other way kung hindi kailangan mo talagang i-integrate. Time rates ito, no? So this function of time rates. Punta tayo sa before we go, punta tayo sa fluid flow in pipes. Kanina, meron tayong pipe problem, di ba? Pero ang basic lang 'yun ng Bernoulli energy equation. Punta tayo doon sa kung tayo mismo ang mag-calculate ng head loss ng pipe. Okay, yung head loss. So dito papasok si Darcy, si Mannings, no? So sino pa? Higgins, William. Okay, just memorize siguro yung sa metric na. Hindi na bumabalik yung yung dati English system. Kaya titingnan mo sa mga reviewer, nandun pa rin yung formula pag in feet, in cubic foot per second. So, but I believe now is fully na tayo sa in meters. So, just memorize lang yung yung naka meters. Iba yung coefficient kasi. So meron ni Darcy yung head loss. Ano ba itong head loss? No? Yung head loss in pipe. Meron tayong major loss, meron tayong minor loss. Yung major loss, this is a function of length and diameter at saka velocity. Okay? Kaya makita mo dyan sa equation, paano kaya ng equation, nandyan yung L, nandyan yung D, diameter, or maybe discharge, at saka velocity. Ito yung major loss due to length of pipe, due to friction. Yung minor loss is yun yung, let us say, mag-change yung diameter. Okay, may angle, 90 degrees. Meron siyang 45 degrees. From, let's say, 100 to So, it's a certain coefficient times velocity head. Mga minor loss lang yun. But let's focus on major loss kasi ito yung laging kino-consider. Major loss in pipe. That is, first is Darcy. Yung F, L over D, V square over 2G. Yung F is friction factor, L is length of pipe, no? And D is diameter, velocity over 2G. Now, sometimes, mas madali, i-express mo in terms of Q. Palitan mo yung velocity in terms of Q over area. Area is, tawag ito, yung area in terms of diameter, may makuha kang equivalent head loss. Now, meron tayong equivalent equation. Yung equation nito ng Darcy, yung Darcy weighs back. Okay? Hindi yata na isama. Anyway, so yung equation nito equals 0826 F L Q square over diameter anong formula? 0.0826 F L Q square over D 16 over 16 over
Over 2G. Over 2G.
over 2G. No, in terms of diameter. If you replace B, tanggalin mo yung V, palitan mo ng yung Q equals, di ba? Ano yan? Area times velocity.
Velocity.
Then therefore V equals Q over area, where area is pi over 4D square. Meron kang equivalent equation ito eh. 0.0826 F L Q square over D
Square over 4.
over, yung derived na. Halimbawa, ito. F, then L, then over D, no? Okay. Yan. L over D. Then yung V square. So, what is your V? Your V is Q over area. Yung area mo is pi over 4. So, pi over 4 D square. So, over area, 3.1416 over 4, no? Then D square. Tama? D square. Area yan. So, Q over area. Then, square mo pa ito. Then, square mo pa. Then, square mo pa. Then, over pa ng twice of 9.81. Okay? So, yung kakalabasan yan, yung head loss mo, formula ng head loss, 0.0826 FL Q square. Kasi, i-square mo pa yun eh. So, Q square over diameter raised to
D5.
16 over 3. Tama? Check nyo.
Raised to D5 yata.
No. D over 5?
D raised to 5.
No. Raised to 5. Diba? D square. Kasi square, tama. Square tapos plus 1, raised to 5. Ayan, raised to 5, not 16. I-Mannings yung 16. Ayan. Actually, ang in-highlight ko lang is yung generic equation. The reason is, itong 0.0826, may derive mo ito. Ito kasi yung FL over DB square over 2G, generic yon. So, kaya mong mapaglaruan yung unit. No? Kasi, pag ito in meters, ito yung H, yung L, yung Q, no? All in meters. Ito naman yung 10.29 Mannings formula. Ito yung pinakasikat din sa open channel eh. Mannings formula. 10.29 N LQ squared over D 16 over 3. Ito yung sa Mannings formula. Yung N is roughness coefficient. No? D is diameter of pipe, L is length of pipe. As you notice, they're all a function of L. So a function kung gaano kahaba, tapos yung diameter ng pipe. Ito yung sinasabing major loss. Major loss, friction loss in pipe. So yung isa is Hissens-Williams formula. No? Hissens-Williams formula. Tatlo lang ito ang pinaka common na ginagamit pang solve. Maybe there are some, but for board exam purpose, meron siyang itong tatlo lang ang laging ginagamit. So Q equals 0.278 C D raised to 2.63 S raised to 0.54. So merong isang equation in terms of velocity. Now I suggest ito lang ang memorize nyo, pwede na. Kasi kung gusto nyo in terms of velocity, di palitan mo lang ng Q ng area times velocity. You can still resolve. So, sa Hissens-Williams formula, kung mapapansin nyo sa mga pocketbooks, merong equation in terms of velocity na iba yung coefficient. So, I suggest, isa lang. So, Q equals 0.278. Then, C, D, 2.63. S raised to times S raised to 0.54. Now, what is C? What is S? Yung C is Hissens-Williams coefficient. Normally, 120, 110, 90. Yung S is slope of energy grade line. Alright? Now, so, mamaya, I'll explain why, tawag nito, ang head loss I used to express in terms of Q at saka yung H. No? So, ang kailangan kong equation is actually etong Mannings. Tama na itong pagka-arrange ng Mannings. Tapos yung Darcy, yung H is 0.08628826 FLQ squared over D raised to 5. Tapos yung Hissens-Williams, I suggest replace H in terms of express etong S na ito. Ups. Okay. Yung etong oops, ay, bakit ayaw? Okay. Etong S, palitan mo palitan mo ito ng yung S equals to head loss over length. No? Kung papalitan mo yan ng yung S head loss over L, may makuha kang equation of head loss, a function of Q. No? But by the way, yun lang ang kasi magagamit natin mamaya sa pipe networks. Etong naka-highlight kasi ito ang sa tingin ko mas madaling i-memorize. Ayun lang siguro tapos yung 0.0826 kaya mo nang ma-derive yun eh. Yung Hissens-Williams kung in terms of head loss, kaya mo rin siyang ma-derive. So ito i-memorize nyo. Lagay niyo sa tapos i-familiarize nyo lang, no? So ito yung pinaka-common sa board exam. Itong tatlong equations. No? So, may board exam nga given yung Q, find the diameter, given head loss using Darcy, using Mannings, using Hissens-Williams. Ang dali lang actually sa board exam, tawag ito. Yung application, kumbaga, no? Problema nga lang, pag hindi alam yung formula, iyak na. So, ito yung Hissens-Williams. Pag gusto nyo in terms of head loss, L, Q over 0.278. C, D, 2.63 raised to 1.85. Saan galing yung 1.85? Yung S, kung tanggalin mo itong S, express mo ito nung di ba ito yung kanina, yung head loss over L. Kung ibaba mo yung yung head loss over L, yan yung S. Ni-raise mo ng 1 over 0.54, yan yung 1.85. Yeah. So galing, madali lang yan. So Q over 0.278. So yung Q, divide mo ng 2.78, 0.278. Itong CD, 2.63. So equal yan sa S, 0.84. But yung S mo is head loss over L. To get rid of 0.84, erase mo siya ng 1 over 0.54, and that is 1.85. So tingnan mo, 1 over 0.54 is 1 over 1.55. Yan yung ano niya. So itong tatlong equation, as I've said, ang kailangan yung i-memorize pagdating sa pipe system. So mamaya sa application. Pero may mga board exam katulad ito dito sa SPLE. Ito past board exam sa SPLE. Given the head loss, even sa Pilipinas, nakailang base itong binigay. SPLE rin, ganun din. Given discharge, given the head loss, given yung length, compute the diameter. Di kung hindi mo alam yung hindi mo alam yung tatlong equation, wala na. So dapat alam mo yung Darcy, alam mo yung Mannings, alam mo yung Hisens-William. Okay? So ngayon, tawag ito. The solution is just simply substitute, no? Substitute mo lang yung tawag ito. Substitute the value Q.8 L 900 H 0.4. Ito yung mga bonus minsan sa board exam, no? Kung alam mo yung formula, pag hindi mo alam, patay na. So H 0.0826 FL Q squared raised to Q squared over D raised to 5. So basically direct substitution, no? So D is 0.735. Now using Mannings, etong Mannings 10.29 and squared LQ squared over D 16 over 3. Di one unknown, one equation. Remember, this Manning equation, mamaya may encounter nito sa open channel, is practically the same, no? Open channel. Mamaya. Ngayon, H is given, Q, L given, N is given, 0.0140. By the way, pag Mannings ang sinasabi, ang pagkakaiba lang nun is given yung roughness coefficient, yung N. Minsan kasi hindi naman sinasabi use Mannings. Pero ang binigay is roughness coefficient. Mannings formula yon. Pag F, normally, ito yung standard sa mga libro F yung binigay. Friction factor, Darcy yun. Pag sinasabi coefficient more than 100, 90, 120, 140, edi Hisens-William yun. Alright? So, yun yung mga sinasabing friction coefficient. Ayan, direct substitution, diameter is, magkaiba yun. Magkaiba yung sagot niya. Iba't ibang approach, iba't ibang formula, of course, expect you have different answer. Using Hisens-William, given C, 130, then you have Q is 0.278, C, D, 2.63. Mapapansin mo, yung formula ko na ginagamit, wala namang head loss, di ba? But I know that yung S can be expressed in terms of head loss over length. O, di ba? Kahit ito lang ang minimorize ko, kaya ko pa rin siyang paglaruan. O, di ba? Pwede mo pa rin. Kahit hindi mo, kasi mahirap memorize So, kaya naka-highlight ko kanina yung madaling i-memorize. Q.278 C D raised to 263. S raised to 0.54. Yan. So, you have, yun, yung S ko is 4 over 900. Yeah, raised to 0.54. Diameter, C, 130. Yeah, 0.8 yung you can solve. No, you can solve diameter. So, diameter raised to 2.63. Alam mo kung paano i-solve yun. 0.8 divide 0.278, 130, and 4 over 900 raised to 0.54. Tapos, raised to 1 over 2.63 to solve the diameter of the pipe. So, 0.714. So, as you notice, different answer. Magkaiba yung sagot niyan kasi magkaiba yung approach. Darcy, Mannings, and Hisens. So, of course, dapat itong mga formulang to, you should, of course, memorize this one. Kasi, kailangan mo pa rin ito doon sa pipe system, pipe network. No? Okay. So, ito yung mga basic 3 equation pag-solve nung head loss nung pipe with given head loss, given discharge, given L, depende. So application ng pag-solve of the major loss nung pipe. Okay? Major loss nung pipe. Now, ito, meron pang oras. Series and parallel pipe. Ito, mga application na ito sa head loss. Okay? Series and parallel pipes. Ito, pipe networks. Di ba? So, ang kaya lang natin pang board exam, parallel, series. Pero pag naka-loop na, no, meron ding approach. Yung pipe, halimbawa, ito sa local, dito sa Qatar, no? Hindi lang naman to normal series and parallel. Network na ito, naka-loop na eh. Yung to be honest, may solusyon, no? Yung parang sa electric flow, nga lang medyo mahaba yung solusyon. Okay? Yun talaga yung real world na pag-analyze nung flow nung pipe system. So tapos apply nung correction. Wala pa akong nakita sa board exam na dahil mahahaba yung solusyon. Kasi mag-assume ka ng flow tapos i-correct mo lang later. Ang so far na meron sa board exam is simple series and parallel. Pero walang walang as in looping, no? So series and parallel, ang titingnan mo lang dito is yung concept nung head loss at saka yung Q. Ang equation mo dito is equation ng Q at saka equation ng head loss. Okay, una. Halimbawa, meron kang ganito. Yung pipe 1 is nakaseries sa pipe 2 and 3. Alright? Nakaseries yan. Okay? Pero yung 2 and 3 are parallel. Okay? Yung 3 and 4, series. Which nakaseries dun siya sa 5. No? Nag-merge dun sa pipe number 5. Kailangan nyo lang intindihin is yung equation. Madali lang yung in terms of Q. Kahit nakadapa tayo, nakapikit, ang alam natin is Q in equals to Q out. So, walang problema yan na sabihin kong yung Q1 equals to Q2 plus Q3. Walang problema yan. Pwede ko sabihin yung Q4 equals to Q3 kasi nakaseries yan. Pwede ko sabihin yung Q5 equals to Q1. Di ba? Walang problema yan. Ang problema na minsan na nakakalito is yung sa head loss. Okay? Ganito. Kaya ito yung sabi ko kanina, yung energy grid line, dapat kabisado natin yan. Okay? Ngayon, ganito lang. Look at Q1, pipe 1. So, energy grid line goes down in the direction of flow. Kaya nagkakaroon siya ng downward trend dahil ang flow is to the right. So, ang is yung energy grid line is going downward. And ito yung head loss 1, right? Now, yung end nung pipe 1, saan nag-end? Yung end nung pipe 1, di ba ito yon? Tama. Yung energy nung end nung pipe 1, yung energy level nung end nung pipe 1, do you agree that energy level is up to here? Di ba? Tama. Yung start ng pipe 2 at saka start nung pipe 3, do you agree na nasa the same junction ng end nung pipe 1? Do you agree na yung energy available to pipe 2 at saka yung energy available at the start nung pipe 3, yung energy available niya is eto bali yun? Tama? Yes, ito yung total energy available to the start of pipe 2 at saka start ng pipe 3. And yung energy available noong start nung pipe 5 is ito siya. Tama? Di ba? And yung energy available at the end of pipe 2 is ito din siya. And at the end of pipe 4 is ito din siya. Di ba? Kaya, in terms of equation of head loss, no? Mapapansin nyo dito that yung head loss 2, equation of head loss, no? Mapapansin nyo dito, that yung head loss 2, tama? Head loss 2. Di ba ito yon? Ang head loss 2 is yung change nung energy level at the start nung 2. Di ba ito yon? At the end nung 2. Di ba ito yon? Tama. Therefore, the difference between that level is yan yung head loss 2. So, ito yon. Ito yung naka-highlight, head loss 2. Na kung saan, that head loss 2, equal yan sa head loss, the sum of head loss ng 3 at saka 4. Kasi nakaseres yung 3 and 4. Tama? So, meron ka ng equation. So, ibig sabihin pala, yung 3 and 4 nakaseres. So, the sum of head loss ng 3 and 4, no, since nagsama-sama sila, okay? At the end of, at the start of 5, nagsama-sama sila. Ibig sabihin, the sum of head loss ng 5-2 at saka the head loss of 5-2 equals to sum of head loss ng 3 and 4. So, gano'n. And the head loss of the system, the total, is of course, yung head loss 1 plus head loss 2 plus head loss 5. Baka kasi, let's say, find the total head loss of the system. Baka i-add nyo yung 1, 2, 3, 4, 5. Hindi ganon. Tama? Hindi ganon. Yung total head loss ng system. Ang total head loss ng system is, it can be head loss 1 or plus head loss 2 plus head loss 5. No? Kasi yung head loss 2, equal lang yan sa head loss 3 and head loss 4. Ang tanong, bakit ko hindi ko i-add yung 3 and 4 in solving the total head loss? Hindi. Kasi yung head loss, vertical, lang yon, yung energy level lang yon. Since parallel kasi itong yung 2 at saka 3 and 4, hindi, iisa lang yan. Hindi mo pwedeng i-add. So, the point here is, in series and parallel pipes, tandaan nyo na, okay, dalawang equation lang ang involved dyan. Yung head loss equation at saka yung Q equation. So, eto siya. Let's say, head loss, let's say Q equation, Q1 equals to Q5 equals, Q1 equals to Q2 plus Q3. So, therefore, I can say that Q2 plus Q3 equals Q1 also equals to Q5. That is the Q equation. No? I call this at Q equation. Ayan. Q equation. So that is discharge equation. Yung isa naman is yung head loss equation. And that is, ano yung head loss equation? That yung head loss 2 equals head loss 3. No? Or head loss total equals head loss 1 plus, okay? Ito na, isulat ko na lang. Okay? Not isulat. I-type ko na lang. H equation. No? H equations. Ano yung H equation? In this case, H2 equals H1, H3 plus H4. Then, H total equals H1 plus H2 plus H5. Okay, ganyan. Yan yung total head loss ng system. O, ganyan. So, dito ka lang iikot, kumbaga. No? Dito ka lang iikot. It's either Q equation or yung head loss equation. Okay? So, isang problem before we mayroon pang 2 minutes. Okay? Let's try to solve problem. Ang dali lang actually sa pipe system. Okay? Pag board exam, I'm talking about board exam. Wag lang yung pipe network tapos nag-loop. Kasi dito yung even sa reviewer, mahaba yung solusyon. Pag board exam lang, ganito lang, walang problema yan. Pag alam mo lang yung head loss equation, tapos, no? Halimbawa, ganito. Series at parallel pipe. Pipe system deliver actually this is past board exam, to be honest, no? 350 liters per second, shown in the figure. Friction factor for all pipe, 0.015 except 0.014 for outlet pipe. So yung 1, 2, 3, 4, 0.15. Yung 5 is 0.014. 0.015 at saka 0.0114. What is the flow in upper pipe? Yung pipe 2. What is the flow in the lower pipe? Pipe 3 or pipe 4? Parehas yun kasi naka-series. And total head loss due to fraction nung system. O, di ba? Baka i-solve nyo lahat ng head loss tapos i-add, tapos mali. Di ba? Tandaan that eto meron tayong naka-series at saka parallel. Okay, paano natin i-solve? Okay, pag ganitong problem, normally, tinatabulate ko siya. Tapos, sinusolve ko yung head loss in terms of Q. So, ganito. Okay? Find Q2, find total head loss. Di ba? Yun yung tinatanong. So, ganito. Then, since ang binigay sa problem is friction factor, may sinasabi ba dito na use Mannings? Use Darcy? Use Hissens-Williams? Wala, di ba?
CMS,
For exam, friction factor, that is for Darcy. Pag roughness coefficient or roughness constant, normally that is Mannings. Ayan yung mga common ano. Kasi may mga board exam talaga na medyo hindi kumpleto ba yung paggagawa nung hindi klaro. So of course, automatic na gawin mo na ganun. Friction, Darcy ito. Using Darcy, kasi friction factor ang binigay, di ganito na siya. Ano yung Darcy? 0.0826, di ba? FLQ squared D raised to 5. Ipasok mo yung diameter, length, and F, you have head loss in terms of Q1. Okay? Meron kang Q, by the way. Ang Q mo is, ano yung Q dito? 0.35 or 35 liters per second at 350 liters. That divide 1,000, that is 0.35. So ipasok mo yung yung Q na 0.35, yung Q1 at saka Q5, no? So this is ito? Q1 0.35. Okay? This is 0.35. Lagay mo dito equals 0.35. Okay? Ganun din dito 0.35. Kasi yun yung discharge doon sa system, di ba? So, ipasok mo yung Q1, 0.35, 0.15, 0.015, 150, tapos diameter, 202. So, yung equation natin is, it should be in meter. So, dapat yung pagpasok mo sa equation, dapat should be in meter. 0.0202. No? So, 0.0826, 0.015, L is 150, Q is 0.35, divide ng 0.202. Raised to 5, you have 66.53. No? Then, ganun din sa pipe 2. Ang problema sa pipe 2, hindi mo alam yung Q2. Hindi mo alam yung Q2, problema mo yun. So, ibig sabihin, yung head loss mo in terms of Q2. Di ba? Q3, hindi mo rin alam in terms of, ganun din, in terms of Q3. Q4, abay, alam mo ba yung Q4? Hindi mo pa alam. So, ipasok mo yung mga variable, available data, but in terms of Q. That is your head loss. Then, number 5, okay, meron kang length, okay, meron kang Q, masolve mo yung head loss. Napapansin nyo, ang kinuha ko lagi, pag ganito, pipe network, kunin mo lang yung head loss against Q. Kasi yun yung equation ng gagamitin mo ngayon. Di ba? So, meron ka ng head loss in terms of Q. Okay, meron kang head loss 2, head loss 3, head loss 4, and yung head loss ng 1 at saka yung 5 is yung number, specific number. So, yung H2, H3 at saka H4 na lang ang problema. So, anong hinahanap dito? Yung total head loss, Q3 at saka yung isa is Q2 at saka Q3. Di ba? Ngayon, diyan ka na magsimula ng ng equation. Anong equation mo? Okay? So, anong equation? Di ito. You have H1, H2, H3, H4, and H5. So in this case, I can say that Q3 equals to Q4 or H2 equals H3 and H4. So K equation, Q2 plus Q3 equals Q1. Q1 is 0.35. So yung equation 1 ko. Right? Then, I can say yung head loss equation. Head loss 2 equals head loss 3 at saka head loss 4. No? Then, my head loss 2 is 1097.Q2 squared. Then, head loss 4, head loss 3 given then in terms of Q. O, di ba? But we know that Q3 equals to Q4. So, pwede kong ma-simplify ito. Di ba? So, magiging, ano na yan? Ilang equation na? Equation 1, equation 2, ang equation 2 is ito yung ano sa baba. Q 1097 to 71, 46. So then equation 3 is Q3 equals to Q4. So you have here a simultaneous equation. 3 unknowns, 3 equation. But hindi naman gano'ng ka-complicated, di ba? Kasi ano mo lang i-simplify mo lang itong yung Q3 equals to Q4. Eh di ma-simplify, magiging Q2 against Q3. So magiging 2 unknowns to equation na lang. Simplify mo yung equation 3, pasok mo sa equation 2. So you'll have equation 4 in terms of Q2 and Q3. Hindi naman ganoon ka-complicated, kumbaga. So but anyway, so simultaneous equation, kahit hindi natin, kayo na mag-simplify, you can solve there, check nyo na lang, Q2 equals 0.122. And if you know Q2, then you can solve Q3. So 0.35 minus Q2, you can solve Q3. And the total head loss, as I've said, is in this case is H1, H2 plus H5. So kung meron ka ng Q2, meron ka ng, of course, masolve mo yung H2. Then you can simply add the head losses to solve the total head loss ng system. All right? So head loss 1, head loss 2, and saka head loss 5. Head loss 1 and head loss 5, meron ka na 66 and 2.7. Head loss 2 is 10.7 times Q2 squared. So 0.12, right? 0.12, 0.012 Q squared. You can solve you can solve H2. Yes? So 1097 times 0.12 squared plus 66 plus 2.67, that is your total head loss. All right? So that's it for this Friday. So next is yung balance is yung pipe networks, no? 3 reservoir and yung mga other application ng Bernoulli, yung pipe system. So God bless. Thank you for listening for this Friday.
Thank you very
Safe.
much, Press Lars. Thank you. Thank you very much.
Okay, thank you, Chairman. Thank you.
Thank you so much.
Thank you, sir,
And,
Sir Lars.
Yeah, you're welcome. You're welcome.
Thank you, Sir
next,
Lars.
for
Yeah.
the,